thing for mock?
So depending on how many practice assignment they attempt, and if they attempt to mock, there is some additional 5 marks on that. It's in the grading document, they can check.
Okay. So you have that student handbook with you, right? So in that there is a grading part and you can check.
So I have wanted to ask like one clarification on the mail we got for that grading pattern for all courses, like the prorated version of the internship. It was regarding some quiz. So I want some clarification on that.
Okay, see these non-technical things we will discuss at the end of the session. Okay. So
okay.
Today we are going to discuss, our main agenda is to solve and understand the problems in mock. Okay. So even Professor Andrew will be joining this session. Okay, he's there. So sir will also give some ideas how to solve each and every question in the mock, so that it might help you for preparing quiz 2 as well as solving the paper quiz 2. So this might give you some help. Okay. So we will go one by one, question by question, and we will try to solve it and understand how the process of solving is.
So sir, Z-square table will be in the question in the quiz 2.
If necessary, we will give you the Z square. What is Z square?
Sorry, Z score.
Can you?
An FZ function, I think, sir. FZ function asking.
You are asking about the standard normal table, is it?
Yeah.
See, whatever the necessary values required for problem solving, as we gave for quiz 1 also, right?
Yeah.
So that is how it will be.
Okay. Got it. Yeah.
Is my screen visible?
So just one.
Yep. Yes, sir.
Yes, sir.
Okay. I think Andrews are also joining. Good evening, sir. Sir, would you like to say any words before we start the session?
Sorry, Srikanth. Sorry for the delay. Please go ahead. I have nothing to say. If there is any issue, I'll pitch in. Okay.
Okay, sir. Sure, sir. Okay. So as I already said, we will go by question, and we will try to solve the question by considering some steps involved in this question, and we will understand how each of the following question is being solved. Okay. Let us start with the first question. Okay. So suppose x1, x2 to x10 are some IID samples of exponential distribution with parameter 5. Can I have everyone please be on mute so that it will not be creating any disturbance to every. Okay, thanks. Yeah, so there are some 10 IID samples came from exponential distribution with parameter 5. So lambda given is 5 here. So we asked you to compute the expected value and variance of the sample mean. The sample mean here is x1 plus x2 plus x3 and so on till x10 divided by 10. So we need the expectation of x bar and also the variance of x bar. So how do we solve this? So what concepts do we actually require for solving this particular question?
Is the expected mean of lambda, so it is 1 by lambda. What is the expected mean of exponential distribution? So it is 1 by lambda.
Correct. So
yes.
1 should be.
Hello.
So if x is exponential lambda, so what is expected value of x? So expected value of this distribution?
1 upon lambda.
1 by lambda.
Yeah, 1 by lambda.
1 by lambda.
And what will be the variance of x?
1 upon lambda square.
1 by lambda square.
Correct. 1 by lambda square. So here lambda is given as 5. Correct. So we know expectation of x will be 1 by 5 and variance of x is 1 by 25. Correct. Now what should be our step 2? So So we know the distribution parameters, distribution expectation and distribution variance. So how these parameters are connected to the sample parameters like sample expectation and sample variance. So what is the relation between distribution expectation and the sample expectation?
Expectation is equal to sample expectation.
Correct. So expectation of sample mean will be equal to the expectation of the distribution. So if you don't remember this particular thing also, it's fine. If you know the linearity of expectation, you can get it from there.
Yes, sir.
Correct. So if you use linearity of expectation, then expectation of x bar will be something like so expectation of x bar will be expectation of x bar, we know that is x1 plus x2 and so on x10 divided by 10. So these are x1 x2 here are independent to each other. So using linearity of expectation, we can actually write it like this: expectation of x1 plus 1 by 10 into expectation of x2, like this. So even though if you forget what is the relation between distribution mean and the sample mean, expectation of distribution and the expectation of sample mean, it's fine. Using expectation of linearity, you can get it. So from here you will get, yes sir.
So just one minor point to add. See, you don't need independence of x1 to xn for this linearity. So it can always work with just that one.
Yes, sir. Yes. Yeah. So you can use that expectation of linearity and we will get 1 by 10 times of, here expectation of x1 is nothing but expectation of x, because x1 follows the same distribution x follows. So this is expectation of x plus 1 by 10 of expectation of x, like this, and it will be like 10 times. So 1 by 10 times 10 times of expectation of x. From here we will get expectation of x bar, which is the expectation of sample mean, is expectation of x, the distribution mean. So the distribution mean, we know that it is 1 by 5. Therefore expectation of x bar will be expectation of x, which is 1 by 5 and which is 0.2. Okay. And what is the relation between variance of x bar?
Sigma square by n.
Sigma square by n.
Yeah. So variance of x divided by n. So even this can also be, for this I guess, not I guess, for this we need independence. So each of x1 and x2 should be independent and uncorrelated. If it is independent, they are uncorrelated. So if it is uncorrelated, we can write variance of x bar as variance of, so here n is 10 here. So you can write it like this. So 1 by 10 times variance of x1, 1 by 10 square, plus 1 by 10 square into variance of x2, and so on, 1 by 10 square into variance of x10. Okay. So from here, if you, here also variance of x1 is same as variance of x, because x1 follows the same distribution as x follows. So the parameters will be same. So variance of x1 will be equal to variance of x2, will be equal to variance of x3, and this all will be equal to variance of x10, that will be equal to variance of x. So if you add all those, you will get 1 by 10 square into 10 times variance of x, and it will be variance of x divided by 10. So variance of x also we know it is 1 by 25 divided by 10, that will be equal to 1 by 250, and this will be equal to 0.004. So this is how we solve this particular question. So the expectation of x bar will be 0.2 and the variance of x bar is equal to 0.004. So option B is correct. Okay, before proceeding to the second question, how many of you actually have seen these questions before coming to this session and actually solved these questions?
Yes.
Yes, sir.
Yes, sir.
Yes, sir. Done, sir, on the portal.
Okay, looks like many of you have attempted. And how is the paper? Yeah.
Sorry.
So how do you simplify? I just can scroll a bit down.
Okay.
I want how the simplification of that particular line after variance x by 10 equals 1 by 10
Okay.
squared.
See, in
variance
between,
x1.
I have skipped one step. That's it. So this particular variance of x bar, you can write it as, so just x bar, we know that it is x1 plus x2 and so on plus x10 divided by 10. Correct?
Yes, sir.
So from here, so if x1, x2 to x10 are independent to each other, then we can write it as variance of x1 by 10 plus variance of x2 by 10 plus variance of x3 by 10, like that. So variance of x1 by 10 will be the constant. When you bring constant outside of the variance, it will be squared. So if you bring the constant outside, then that will be like 1 by 10 square variance of x1 plus 1 by 10 square variance of x2 and so on. It will be like 1 by 10 square of variance x10. And here variance of x1 is variance of x itself, because x1 is actually a sample taken from the distribution x. So whatever the x follows, x1 will also follow the same way. So variance of x1 will be variance of x. The same variance of x2 will also be variance of x. Variance of x10 will also be variance of x. So then this will be
This
like,
is a vital point, I think.
huh?
So x1, yeah, this is the main point. So I was confused here. So x1, x2 are taken from the same distribution. So you mean that because since it's the same distribution in the same pattern as x, so the variance of x1, x2, and x3.
Actually, this x1, x2, x10 are samples taken from exponential distribution, right?
Yes, sir. Yes, sir.
So it also follows the same distribution, whatever the exponential 5 follows. So in the question, it is given, right? So this x1, x2, x10 are random variables which follow, which are independent to each other, and also they have distribution which are identical to exponential with parameter 5. So each x1 follows exponential 5 and x1, x2 to x10 are independent to each other. So that is what IID means, right?
So
Independent, identically distributed.
So when we say x for 5, it follows the exponential distribution 5 is lambda equal to 5. Is it?
5 is lambda here. Yeah.
Lambda signifies, it's a basic question, sir. Sorry. What does lambda signify here?
Can you come again?
Lambda. What is the lambda here? Actually, what does it signify?
See, lambda is the parameter, right? Parameter of exponential distribution, right?
So what if they are not independent?
Then you cannot write this variance of x1 plus x2 plus x10 by 10 as like this.
Then how could we proceed for like calculating the variance?
It's not necessary, right? Here, so we don't deal with dependent identically distributed. Did we discuss anything in the lectures or anywhere in the course?
Not really.
No,
I think I don't think we really discussed, but you need to know more things. I think if they are dependent, then you need to know something about the joint distribution, and you have to use that and compute. It's a little bit more complicated. Can be done, but you need to know the joint distribution. At least pairwise joint distribution you need to.
Yes. Okay. Shall we proceed to the second question?
Yes, sir.
So here variance of x would be, what is the variance of x here? Sorry,
variance of x will be 1 by lambda square, right? If you know.
So, yeah, I think the assumption here is you know what exponential distribution means. What I mean, there are various distributions, no, uniform, exponential, Gaussian, Poisson, and all that, right? So, I mean, of course, it's been assumed that you know that distribution. If you don't know it, please go look at the lectures. There'll always be a table given in the quiz which has which will list all the common distributions and their parameters and expected value variance. So you don't have to mug up the formula, but you should know what these names are and what the distributions are, at least a little bit.
So here it will be 1 by 25 into 10, right? The last term.
Yeah, 1 by 25 divided by 10.
Sorry.
It will be 1 by 250. Okay.
Variance is 1 by 25.
Yes, sir.
So it's we have 10 terms right here actually. So
Yes.
10 squared
See.
into. Okay, 1. Yeah, got it, sir. Thank you.
Okay. Yeah.
Thank you, sir.
Okay. Okay, then let's move ahead. So this is
unnecessary.
Okay. So this is the second question. So suppose the random variables x and y are uniformly distributed over the region D. So we have given a region D here, and we said two random variables x and y are uniformly distributed over this region. And in the first part, there are two parts in this particular question. First part, we asked about the joint distribution between these two random variables. So here x and y are continuous random variables, and we are asking you joint PDF of x and y. And the second part is regarding whether x and y are independent or not. So how do we proceed this particular question? So what is the first thing we should do for this kind of questions?
Draw the graph.
Draw the graph.
Identify the region.
Regions.
Yes, exactly.
Correct. So yeah, let's do that. Okay. So we have given the region as region D as 0, 1 cross 0, 1 union 2, 3 cross
0, 1.
0, 1.
0, 1.
So I hope you know how to read this particular thing. So
Yes,
what
sir.
this represents,
Yes, sir.
what this represents. Right? So 0, 1 is the interval of x here, and 0, 1 is the interval of y here. So 0, 1 cross 0, 1 represents
A square.
a square, a region square region. Okay. So this is 1, this is 1. And also there is another region 2 to 3, x runs from 2 to 3 and y interval is from 0 to 3. So it will be somewhat like this. So the region D is actually the union of these two regions. So combining to the two regions is the region D we have. Now x and y are uniformly distributed in this region D. So we have studied in week 5, I guess. So when x and y are uniformly distributed in a region, so how will be the joint PDF of that D? So this is step 1.
1 by absolute value of that area D, region D, sorry.
It's absolute value of D means the area of that particular region D. Correct? So if this is the step 1, then step 2 will be like, so the joint PDF of x and y will be fx of x comma y 1 by area of region D in the interval where x comma y
Belongs to D.
belongs to this region D, and 0 otherwise. So what is the area of this region D?
Sir, one question here. Sir, why do we put modulus sign in the area of region D? Because sir, area can't be negative, right?
Right.
So it will be 1 by mod of D, no?
See, it's just the representation that mod D, we have defined it as area of that particular region D.
Okay, but because is the area not being negative, so if we don't put modulus sign, will it work? Or
No. Don't. I mean, forget about modulus. Just write area of D.
D. Yeah.
It's just some notation.
That's the notation we use.
Okay, sir.
So you can actually write it like this. Whatever I written, it's actually the 1 by area of the region D.
Okay.
Okay. Yeah. So what will be the area of
1
this
by
region?
2. 1 by 2.
Area will be 2.
Area
will be
Area 2.
Yeah.
So the area of this region is 1 and the area of this region is 1.
Yeah.
So the total area will be 1 plus 1, which is 2. So just substitute 2 in place of area of the region D. So it will be 1 by 2 in the region D and it will be 0 otherwise. So this will be the joint PDF of X and Y. So this is the first part. So one part of our question. So it will be like option C will be the correct answer. Right?
Yes.
Yeah. So the second part is, are X and Y independent?
No, sir.
So in order to answer this particular question, so what is the condition for independence? So if you have two random variables X and Y,
marginal density of X times marginal density of Y should be equal to joint density of X and Y.
Correct. So the product of marginal should be equal to joint.
Yes.
Correct. So that is what the condition is. So in order to verify that condition is true or not, what we should find first. So this is the second part.
Marginals of
X. Marginal density of X and marginal density of Y. So here the step 1 should be like, first step should be like find fx of X and fx of fy of Y. Correct? So the marginal density of X and marginal density of Y we should find first. So how do we find marginal density when here X and Y are continuous random variables? So in order to find the marginal densities,
Integration.
Integration.
Yes, sir. If
so
we have to find fx of X, we will integrate with respect to dy. And if fy of Y, we will integrate with respect to dx.
So whatever we want, we will keep it, and whatever the unwanted random variable is there, we will sum it over. So here, when it is in continuous case, when we say summing over, that means we are actually integrating. So continuous summation is what integration means. So fx of X will be integral. So in order to integrate, we need to know the region. So what are the limits? How should be our limits be?
0 to 1.
Half dx.
So we'll integrate across the y limit.
Half dy.
Yeah. So that will be 0 to 1 for one box. Yeah.
dy.
So both things are, yeah.
Yeah. In both the cases, you see, when X is in between 0 to 1 or when X is in between 2 to 3, Y will vary from 0 to 1.
Correct.
Okay. So you choose one X and you see the limits of Y. So with respect to this particular X, the limits of Y is 0 to 1.
0 to 1.
So whatever the X is in between 0 to 1, the limits of Y are from 0 to 1. Even the same works for 2 to 3 also. Even the X is taken from in between 2 to 3, the Y limits will be from 0 to 1. So if you are confused about the two regions, treat it differently and compute it. If you get the same value, then combine it. That's it. Okay. You can do it like this also. So integral 0 to 1 fxy x comma y dy when X is in between 0 to 1, and again it will be same value 0 to 1. The limits are same actually, xy dy when X is in between 2 to 3. Okay, so let us compute this 0 to 1, this value 0 to 1, fx of x comma y when x is in between 0 to 1, what is fx of x comma y? Half. So half dy. So integral half dy, what is the integration of constant?
X and like constant
y by 2.
Y by 2.
How you got this half? I didn't get it. For x for x by dy, how half?
Krishna Mohan, your voice, I can't hear you properly.
I
Can you be a
was
little louder?
I was asking for integral 0 to 1 f of fxy of xy dy, how half, sir? How did you get half?
From the first part. So from the first part we get that, right? So the joint PDF will be half in the region, in this region, and it will be 0 otherwise. So this x in 0 to 1, so if x is in between 0 to 1, so we will be in the region, in this region itself.
Yes.
That means, see, other regions it is actually 0 anyway. So integrating it with 0, you won't get anything. You will get 0 itself. So you can actually neglect that particular region. So this should be actually 0 to infinity, or so you should consider only the support. Till the support we will integrate. That's it. Okay. In this particular case, when x is in between 0 to 1, our y limits will be from 0 to 1. Okay, so we want the marginal density of x. So what we do is we will integrate the joint density function with respect to the support of y. We will sum it over all the values of y in between 0 and 1. That is what this is. So this integral 0 to 1 means it's actually we are summing all the values between 0 and 1. So we will take, so this is something like, if you want to understand it clearly, it is something like fxy of x is constant here and y will vary from 0 to 1. So all the values of fxy of x comma 0, 0 0.00001, like this, it will take all the values and it will actually take the summation. So that particular summation is nothing but the integral 0 1 fxy of x comma y dy. Okay. So we want the marginal density of x, we will sum it over the unwanted random variable. That's it. So that is how it will be. So in this region, our fxy of x comma y will be half. So that we got from the part 1. So part 1 of this question we get it from there. So if you integrate this, it will be like y by 2 and the limits are 1 and 0. And this will be half minus 0. So this is half. So even if I compute this, I will get half only. Correct? Correct?
Yes, sir.
Yes, sir.
So fx of x will be half when x is in between 0 to 1 and 2 to 3 and 0 otherwise. So this is the marginal density of x. So what will be the marginal density of y?
It will be again
x is from 0 to 1.
0 to 1 half dx plus
half dx
2 to 3 half d1. Sorry, dx.
Yeah. So if you see here, now you fix one y in between 0 and 1. Now the x limits are from 0 to 1 and also from 2 to 3. So if you randomly choose y somewhere in between 0 and 1, stripping, so this is what strip means, right? In order to find the limits, so for this, for any y in between 0 and 1, our x will vary from 0 to 1 and as well as from 2 to 3. Correct?
Yes, sir.
Understood this part?
Yes, sir.
Yes.
So our x will vary from 0 to 1 and 2 to 3. So that means the limits of x should be 0 to 1, you have to integrate from 0 to 1 fxy of x comma y dx
plus
and plus there is from 2 to 3
2, 3.
x goes from 2 to 3. Okay. So therefore it will be 0 to 1 fxy of x comma y. So dy or dx?
dx.
dx or dx.
So dx and 2 to 3
Plus
yes. X comma y dx. So this is in between
Y
when y
from
is
0
in
to
between
1.
0 to 1.
1.
And it will be 0 otherwise.
Yeah.
So what is this value? If you compute, what will be this?
Half.
Half.
Half x. And then after completing.
Okay. So this will be 0 to 1 half dx plus integral 2 to 3 half dx.
Right.
So integral 0 to 1 half dx, what is the value of? Just now we computed, right?
X by 2.
X by 2.
So it will be x by 2 and the value will be
half.
So this particular value is half. Okay, no need to compute again. So this will reduce your time when you solve the problems. Actually, you have computed 0 to 1 half dy here. Okay, so that we have computed to it is equal to half. Again, no need to compute here. No need to compute again. See, this value is a half. You know that. Now, what will this value be?
Half.
So again, integral half dx. This is like x by 2. So this is 0 otherwise.
3 by 2 minus 2 by 2.
1.
Yeah, 0 less than
1.
So this will be first part is half plus this is x by 2, 3 and 2 are the limits. So 3 by 2 minus 2 by 2.
Which is half.
This is again half. So half plus half?
1.
So this will be 1 when y is in between 0 and 1 and 0 otherwise. So now tell me, now we found marginal densities of y and x. And you know the joint PDF also. Now tell me whether these two random variables x and y are independent or not.
No.
Yes.
No, sir.
Yes.
Yes, sir.
They are
Independent, sir. Product
Yeah.
is equal to joint.
Yeah. In the region D, so we will consider only the support. Okay. You just consider till support, it's sufficient. So other part it will be 0 anyway. So fxy of x comma y is actually half, and that half is actually half times 1. So this half is fx of x and this one is fy of y. Okay, the product of marginals is actually indeed the joint PDF in the support in the region D.
So just a small doubt, sir. Yeah, for y we are adding both the regions, but for x we have not added. We have calculated it with respect to only one region. So because the limit is same, that is the region or what?
No. See, the strip part, you have to look at the strip part, okay? So you choose randomly x in between 0 to 1 or 2 to 3. So what is the limits of y here?
That remains same, 0 to 1.
0 to 1 only. There is no other extra limit you are going to.
Yes.
But when you consider
that's what
for
I'm
y,
saying. This is that's what I'm saying. This is the logic, right? If the limit remains the same, then we have to consider only one region. If limits are changing, then we have to take all the regions, right? Like for x, limits are changing from 0 to 1 and then from 2 to 3, right?
Okay, this is actually what it actually is. If you look it in the 3D picture of this, so why we actually integrate and why are we actually 1 by area? So what is this joint PDF is actually the 1 by area of region D. So here, if you consider XYZ plane and Z represents the density function. Okay, fxy of x comma y. and let's say this is y and this is x. So this actual picture will be half units above. So the height. So this is not actually, this will not be a rectangle anymore. So if you see it in the 3D picture by considering the z-axis as density of joint density, then this will become a rectangle, cuboid. So cuboid with height half and length and breadth equal to 1. And here also the same cuboid will be there. So the same cuboid. So now you see, if you are integrating means we are actually, see, not integrating. See, this is actually, we are trying to find the area under the curve. Okay, integration means area under the curve, right?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Now, what is the volume under this curve? Area under this curve, this upper curve, this rectangle. It will be half. And here also it will be half. So from there we will get fxy of x comma y is half actually. Okay. And also, in order to compute the marginal densities, we integrate. So if you want to compute the marginal density of x, we integrate along y. So that means in 3D, so I am on 2D paper, representing in 3D will be slightly difficult, but you should understand this particular thing. These are, when we are considering this strips thing, so these are not exactly this straight strip. This will be exactly some plane. Okay, some plane like this.
Did we say some plane with the thickness dx?
Dy, dx. Yeah.
Sir, if you add these two blocks, how much the volume, total volume will be, sir? It is equivalent to
Total
1 or
volume
so?
will be 1, right?
1.
Area, 1.
That gives the
Then,
probability. The total probability is 1.
Then can we apply volume formula over here, means length into breadth into height kind of thing? Then the XYZ would be a bit changing kind of thing. Is it true?
See, these things we know, right? In order to be PDF, if you integrate PDF along the support, you should get 1.
Yes, sir. Deputy value 2.
Right? That is the PDF function, right? If you have any PDF function fx, so if you integrate fx along the support of x, you should get 1.
2D is okay, sir. 2D is okay. I'm asking about 3D only.
See, even 3D also the same thing.
You can apply the volume formula. Height is half.
You can apply the volume formula and you will get actually. That is how we draw these cuboids.
Right, sir. Thank you.
I have a question, sir.
And
Yes.
let me complete this particular thing. So this particular plane, so whatever the x I take, the plane will be same. So the same plane here also I have to integrate.
Cuboid volumes are 1 each, is it?
Half each.
Half each?
Half and half.
In the 2D, we are watching 1 by 1. That's why we are getting confused.
Yeah,
sir. That's all.
Okay, in 2D you are watching 1 by 1 and you just make the height of this particular rectangle, you just take half height. So this will be in 3D. So the height of this cuboid will be only half, not 1.
That is a PDF, is it?
Yeah.
Yeah, that's what confusing now. All right.
Correct. So the volume of this cuboid will be half and this cuboid will be half. If you combine these two, it will give you 1.
Yeah,
so
that's right.
So integrating, so this fxy of x comma y dx dy. So along the support of x and support of y, if you integrate it, you should get 1. You will get 1. Okay.
Sir,
Now we understood the formula better, sir.
Yeah.
There's just a basic doubt on the support. Support is the area where it is greater than 1, is it?
Greater than 0. Actually, you have some density, some chance of that particular random variable taking value. So x can take values from 0 to 1 and 2 to 3 here. In this particular case, x can take any value between 0 to 1 and 2 to 3.
Right.
So that will be the support of x.
Right.
Where our density function has actually some value, some density is there. So where fx is.
And similarly, for y it is 0 to 1, is it?
For y it is 0 to 1.
And for z it is 0 to half.
0 to half.
Obviously, sir. So right now you have drawn that one.
Z has a support or not? Z has a support or not?
Z is actually, we have
That's
defined
a
it
PDF,
as
right?
PDF, right?
That's a PDF. That's a PDF, right?
So why will support come into the picture?
No, I am just looking at the picture of the graph. When x and y, we are referring to the coordinates, and that's all the support. It's the same scale of measure. I was just extending.
No. That is not the case. That is not the case. See, support will be there for continuous random variables. So likewise, we had discrete. In discrete case, we have range, right?
Range, yes.
Yeah. So if it is discrete random variable, we will have range. If it is a continuous random variable, we will have support.
Got it.
Okay. And this
And
particular
that's only for the random variables.
That's only for the random variables. Yeah.
Not for the PDF or PMF.
No. See, these are functions actually. So this PDF function.
PDF and PMF.
PDF is a function. Okay.
Got it.
Sir.
Yeah.
So like
so here, sir, can we complete this, sir? So here the joint PDF is half, and the product of the marginal distributions are half into 1 is half, so it is dependent.
So it is independent.
Sir, on the same thing. So like if we see in respect to the region we draw, so we do that. So like in the, I guess in the previous session it might be I'm wrong. So that if the regions are not touching in any sense, then it's clearly it shows that it's clearly dependent. It's not independent, right? So like in the region like D would have been like 2 to 3 and cross 2 to 3. So it would have been a region separately on the upper side. So we could have told like it's not independent, right? So here also it's, I know that there's a one union thing is there. So like I'm not getting what's the importance of this 1 to 2, the region, which is not we are taking, but still it's separated, but still it's independent. So I'm getting confused in that.
See, it's not about separation thing, kind of thing. See, here if you understand it from the diagram itself, whatever the value I take, y value I can take in between 0 and 1, whatever the value I take, x can take from 0 to 1 and 2 to 3, right?
Okay.
So whatever the value of y, x can take from 0 to 1 and 2 to 3. Okay. So it's not actually dependent on the value of y. Same goes with x here. So whatever the value x takes in between 0 to 1 or 2 to 3, y can take any value in between 0 to 1.
Yeah.
Okay. So if you look in the diagram itself, you can identify whether these two are independent or dependent.
Okay.
So if you vary x, if your y support is varying, the value of random variable, the support of y changes, like the values that y takes changes, then they are dependent.
Okay.
The values that y takes is independent of value of x takes, then they are independent. Here also the same thing will happen. Whatever the x I take in between 0 to 1 or from 2 to 3, my y can take any value in between 0 to 1, independent of x. And for y also the same thing.
Just one minor point. I think if you're dealing with just uniform distributions, that's probably okay, but I think it needs to be slightly careful. It's not just the value taken by y, the distribution of y should also be the same. You do not change that also. So independence is a bit stronger there.
Yes, sir.
Yeah, generally I think in uniform cases that's a good metric. I think the other case is true. If the support of y changes depending on which x you choose, definitely they are dependent. I think that is true. In the other way, you have to just check that additional condition with the joint PDF being equal to the product of the marginal PDFs.
Can we have an example for a dependent case here? Not independent case here?
Okay, I will just show you here.
The picture really?
If it is okay, can you kindly repeat the two conditions you were mentioning, sir?
Yeah, maybe Srikanth, you should do that example in a separate page.
Okay.
Not complicated with this. Yeah. Put it in a separate page.
So suppose we change our region. So the region now is, the new region D1 now is 0 to 1 cross 0 to 1 union 2 to 3 cross 2 to 3. So if the region is like this, now
the new region is 2 to 3, 2 to 3.
something like this. So 0, 1, and this is 2, and this is 3, this is 1, this is 2, and this is 3. So now our new region D1 will be this. Combining these two regions, that will be the D1. Okay. Now you see, when x is in between 0 to 1, what values my y can take?
0 to 1.
0 to 1.
0
to 1. But if my x values is taking in between 0 to 2 to 3, what y values, what the random variable y can take?
2 to 3.
2 to 3.
2 to 3. So depending upon the x values, my y values also changes. Right? So here, when my x is in between 0 to 1, my random variable y can only take values between 0 to 1. The support of y when x is in between 0 to 1 is 0 to 1. But when x is in between 2 to 3, x takes values in between 2 to 3, my support of y will suddenly change, got suddenly changed from 0 to 1 to 2 to 3. Now my y, random variable y, takes values from in between 2 to 3, not from 0 to 1. So depending upon x, my y values varies, my y values changes. Okay.
So they are not independent.
They are not independent. They are dependent to each other here. So one on particular one value, whatever x value the random variable x takes, my y value that y takes is dependent. Correct. If 0 to 1, if x is in between 0 to 1, then corresponding to this, my y values will be in between 0 to 1. So this particular random variable watches this particular random variable x. So okay, if x is taking in between 0 to 1, okay, I can take the values in between 0 to 1. If my x is suddenly taking values between 2 to 3, then y values will also suddenly jump from 0 to 1 to 2 to 3. Okay.
Right, dependent or there.
Yeah. So there is some dependency between.
Sir, in this case, if I have to calculate marginal of x, right? So I will calculate it for both the regions and add, right?
So if you want to calculate the marginal, that is why I said. So
Yes.
even you don't collectively take the complete region every time. So you can piecewise. You can actually.
I can do piecewise.
You can actually do piecewise.
Yes, and I will have to add both the marginals. Like one.
No.
While calculating marginal effects, first of all, I will integrate with respect to 0,
Okay,
1
let us
region.
compute. Okay, let us compute.
Okay,
Let us compute and see. So in order to compute marginal of x, so that means
integrate with respect to y.
Integrate with respect to y. You choose 1x, and the limits of x is, when x is in between 0 to 1, the limits of y is from 0 to 1.
0 to 1, sir.
Okay. So that will be 0 to 1 fxy of x comma y dy when x is in between 0 to 1. Now what if x is in between 2 to 3?
Y is also
what will be the limits of y?
2 to 3.
2 to 3. So 2 to 3 fxy x comma y dy when x is in between 2 to 3. So this is what it will be. So you compute it. So here also fx of x comma y will be fxy of x comma y will be half in the region D and 0 otherwise. Correct? The area will be 2. So 1 by area of the region, it will be half. So it is uniformly distributed. Okay. Here we are considering only the case of x and y are uniformly distributed. In D, in this region D. So now this will be 0 to 1 half dy, and even this is also 2 to 3 half dy when x is in between 0 to 1, 2 to 3. So the value of this is half. So we are going to get half when x is in between 0 to 1, and the same half when x is between 2 to 3. So this will be half when x is in between 0 to 1 or 2 to 3, and 0 otherwise. Now, what will be the marginal density of y?
Same,
sir. Same. 1 by 2. 0 to 1, 2 to 3.
Okay. Let us see. So initially, what is the marginal density of y? In the above case, what is the marginal density we got? 1. But here, let us see how to. So if you take any random value y in between 0 to 1, my limits of x are from
0 to 1.
0 to 1.
Only 0 to 1. There is no more
2 to 3.
The support of x is actually 0 to 1 only. Here.
Yes, sir.
Here.
Yeah.
Okay. So what we have to do? We have to integrate it from 0 to 1 half dx when y is in between 0 to 1. What if my y is in between 2 to 3?
1 by 2 dx.
Y is in between some y. If you choose some y, what are the limits of x here?
2 to 3.
2 to 3.
2 to 3.
2 3.
2 to 3. 2 to 3 half dx.
Yes.
So we are going to get half in the region y is between 0 to 1 and 2 to 3, 0 otherwise. Now you see, what is the product of marginals now we got?
1 by 4. 1 by 4.
1 by 2 times 1 by 2, which is 1 by 4. So here
1 by
it is half.
4.
1 by 4 in the region D. And what is fxy of, what is the joint?
Half.
Both are not equal.
Dependent.
So from the computation part and from visually also, we have understood these two are dependent on each other.
Please write dependency with the red mark kind of thing on the figure.
Please write.
Yeah, they are dependent now. Please mention that one, sir, please.
Okay. So now this xy are dependent. This xy, in this particular case. Okay. So when x and y are uniformly distributed in some region D, if we say that, then by looking at the graph also you can say if you change x, if your support of y is changing,
then we say they are dependent.
Then you can say they are dependent when it is uniformly distributed case.
Yes.
Okay.
So I don't think that uniform is required. I think that's true.
That's
you can
true,
say
sir.
it's dependent.
Yes, sir.
But if it doesn't change, if you want to say independent, then you have to check the product.
Yes.
Okay. So for
Yes, sir.
dependency, this is sufficient. Okay.
Yes, sir.
If
Thank
the
you, sir.
support of y changes when x changes, then they are dependent. Okay.
Yeah.
But make sure whatever sir said, if it is not changing also, don't conclude that it is independent. Both are independent. So just find like this. Find the marginals and identify the product of marginal, compute the product of marginals that should be equal to the joint rule. Okay, done.
Can I generalize this one? If the support of y is same for all regions, then they're all independent.
No, that is what we said, right? Be cautious about the independence case. So it doesn't mean that if your support of y doesn't change, doesn't mean that they are independent.
I could not visualize that one. If we suppose we are maintaining
So first thing, see,
same.
let me interject. Sorry. See, the mathematics is a bit different from English in that way. You know, if in English, if you say if A happens, then B happens. Usually, you can also reverse it. You can say if B happens, then A also happens. It in physical English descriptions, that's always true. So in mathematics, you'll be slightly careful. Like if A implies B, it's not true that B will imply A. Okay. Not A will imply not B, but B will not imply A. So it's a bit twisted. So this is one of those cases where you have to be slightly careful. Anyway, I'll let Srikanth describe that.
Yeah. So
I was thinking of
yeah.
I was thinking of really pulling down the floating square onto the x-axis. Similarly, going to add up another couple of squares, and all put together is going to be 1. Then all are independent, is it? Is it my imagination is right or wrong?
That is geometry, sir.
What are you doing? You are putting that above square.
No, I'm pulling the floating square now to the x-axis. Okay, it's sitting on the x-axis. Yeah. Right.
Why
and I'm adding.
Sorry. Just a second. Why? Can I ask like why you are?
No, yeah. The reason, the conclusion what I'm going to come out at is if the support for y is same for all the squares, then they're all independent, right?
No. See,
No.
I will write the statement. Okay, just understand it from here. If by changing x, values of x, if by changing the values of x, if the support of y changes, then, so this is like if then, it's not like if and only if. It's not by implies.
Okay.
If you understand the logic,
then they are not
correctly,
independent. Then they are not independent.
They are dependent or they are not independent.
Yeah, I'm with you. Yes, I'm with you.
Okay.
Okay.
So see, can I go with the logic? If you understand logic, can I bring logic into this picture?
Yes, please.
Okay. So you know truth tables or logics like P implies Q.
Okay.
So there are two statements P and Q. If one statement is implying the other statement, so this will not imply that Q implies P. So this conclusion you cannot draw.
Or even bit more strange. You can't say if not P will imply not Q. No, that's the other thing. It's a bit strange in logic.
Right. Even there is one more thing you cannot bring up. This is okay. Negation P or not P. Okay.
It's
So
not
even you
P.
can't draw this conclusion. So that means if the negation statement of this is if you change the values of x, if the support of y does not change, then they are independent. That is also doesn't follow. That is what the statement you are trying to say, right? So the not statement of
exactly
P and the not statement of Q. So you are saying that by changing the values of x, if my support of y does not change, then they are independent.
Right.
But that doesn't follow. That doesn't follow from this statement.
That follows only for uniform.
No, even.
So can we say that? Hello. Can we say that to be independent, one of the marginal should be 1?
No. See, we are going out of
Means the support
logics.
of
We are
x,
missing.
if the support of y will not going to be changed by changing x, then y will always be fx of y will always be x, na, sir. So always be 1. If the support is not changing of y, then it will always be 1.
Why will it always be 1?
Over entire range of x, entire probability.
So you are only talking about this uniform case, is it?
Yes, only for uniform.
Okay, maybe. Just a second.
For uniform, I think that's true.
Yes,
so
yes.
if it's uniform, then it'll be true. Otherwise, it's not generally.
Correct. So if it is uniform, either one of the marginal densities should be 1. Will be 1.
No. I think the way to correctly say that is if the joint distribution is uniform over a region, and when you change values of x, support of y does not change, then they are independent. That is true, I think. Okay.
Yeah. Okay. Let's not complicate this too
much
here.
I think some people are saying too much time spent on this question.
Yes, sir.
That's true. But think about this a little bit more. I think it's an interesting thing to think about.
So see this. Consider this as
and also let me just interject here. It's not also very idle. See, what will happen normally is you will get a lot of data in any data science problem. You'll get a lot of data, and you have to first start by plotting, let's say, the scatter plot of two things. The scatter plot of two columns or something is like the support, right? Isn't it? So you'll get one big cluster of points, and now the shape of that support can tell you a lot of information about the independence and dependence. Right? So these are not just some idle, theoretical calculations. They're very, very useful in practice when you do scatter plot and start thinking about dependence, correlation, and all that. If you get something like that, then maybe you can think, okay, there is dependence here. If you say that it seems to be the same, it's not independent. So these kind of notions are quite useful in practice, and people use it every day.
Sir, over here, can I request something, sir? We, you have uploaded some collab files and all like that in the this one, sir, our site. And can we have after this, please, session for explaining or discussing that one also, please?
Collab session for collab, is it?
No, collab file has been given in that.
No, I think he's talking about the 2D integration collab file.
And
maybe that can be done separately. I don't know if
that's what that is the request I am making now.
Yeah, you can ask in the forum also. Yeah, Srikanth, let's move on to the next question.
So actually the question is this, right? Have you understood the solution of this particular question? Everyone?
Yes, sir.
Yes, sir. If any region is given and it is uniformly distributed, we should know how to compute the joint PDF and as well as the marginal PDFs. And you just have to identify whether X and Y are independent or dependent using the condition of independence. So those are the required things in order to solve this particular question. Okay.
Okay, sir.
So let's go to the third question then. So I guess this question, this is about the moment generating functions. So if you have x1 and x2, which are IIDs of x, where x is actually a discrete random variable with probability mass function. So we have given you the probability mass function. So p of x is equals to k as 0.3 for k is equals to -4, 0.2 for k is equals to 1, and 0.5 for k is equals to 2, and 0 otherwise. This is the probability mass function we have given you, and we asked you to find the moment generating function of x. So this is a discrete case. So for discrete case, what is the moment generating function? How will be the moment generating function be? So if x is discrete random variable,
PMF into e raised to lambda x.
PMF summation.
Yes, summation of PMF.
The expectation of e to power limit x, sir.
So many have forgot, is it? Moment generating functions and everything. Okay, let me revise them. So when x is a discrete random variable with some PMF fx of x, so some PMF fx of x, our moment generating function, which is mx lambda, denoted as mx lambda, is actually the summation of x belongs to support of x. Sorry, here it is range of x. Discrete, it will be range of x. Probability that x takes x times e to the power lambda x. Remember this anywhere in our lectures or?
Yes, sir.
Yes, sir.
So what is when x is, what is the formula when x is continuous?
It's integration in the support of x.
So this will be like integral when x is in support of x. So integrate along the support of x. The same thing. This will be fx of x times e to the power lambda x. Correct?
Yes, sir.
Okay. Now we have given you only the discrete case. So we know this is not required. So now that we have this, now tell me what will be the moment generating function for this particular case. So if this is a PMF, so how is the distribution? So what are the values can x can take?
-4.
-4.
1 and 2.
4, 1 and 2. 1 and
So
2.
the range of x is -4, 1 and 2.
4, 1 and 2.
Correct? Yeah. With probabilities
0.3 for -4, 0.2 for -1, 0.5 for 2.
Yeah. So this is the distribution of x. So we know the PMF of x also here. Now it's just, you just have to plug in the values. That's it. So x can take here, x can take -4, 1 and 2. We know what is the probability that x is equals to -4, what is the probability that x is equals to 1, and what is the probability that x is equals to 2. So 2 steps answer. So it will be like probability that x takes -4 e to the power lambda times -4 plus probability that x taking value 1 times e to the power lambda when x is 1. And when x is 2, it will be like probability that x is equals to 2. Probability that x is equals to 2. X is equals to 2 and lambda times 2. So this will be the MGF function. So this value, and this value you have given me. It is like 0.3 times e to the power -4 lambda plus 0.2 times e to the power lambda plus 0.5 times e to the power 2 lambda. So just check whether this option is given. Yeah. So option B is. So simple. Moment generating function means this is how it is defined. It is defined for discrete case, and continuous case is different. So if it is continuous, be cautious whether the random variable is continuous or discrete, or is the combination of discrete and continuous. Okay. So last case you don't need to worry much, but you just have to be cautious whether the given random variable is discrete or continuous. Here we have given PMF. From there also you can identify that it is discrete, but don't use one formula for the other formula. Okay, you may go wrong, or you cannot compute actually. If you take integration here, you cannot compute anything. Okay, so this is about the part 1. So we have 2 parts here. So this is part 1, and the part 2 is actually a new random variable is there, y, which is actually the sum of the 2 random variables x1 and x2. So we ask you to find the distribution of y. So how do we find this?
First, we have to find range.
Okay, you can actually write on the table. So x, y, and joint PMF of x, y. Okay, x1, y1, right? x1, x2, f of x1, x2, x1 comma x2, and then y is equals to x1 plus x2. Okay, we have x1 can take values -4, 1, 2,
-4,
and this also can take -4, 1, 2. So x1 can take -4 and x2 can take -4. When x1 takes -4, x2 can take 1. When x1 takes -4, x2 can take 2. Okay, we are actually computing the joint PMF of x1 and x2. So -4. So when x1 takes 1, when x1 takes, x2 can take -4, 1, 1, 1, 2, 2 -4, 2, 1, 2, 2. So if there are 3, if the range is 3, you will actually have how many? 3 square.
9.
So if one random variable can take, so how many boxes will be there in the joint PMF? If x1 can take 3 values and x2 can take 3 values. So when you draw, when you compute the joint PMF table, how many entries will be there?
9.
9, correct?
9.
It's actually the product of the ranges. So that many rows you will get here. Okay, even if you forget one row, you will get wrong answers. Okay. Okay, so what is the probability that, so this fx of x1, x2 of x1 and x2 is nothing but probability that x1 takes x1, small x1, and x2 takes small x2 at the same time. So what is the probability that x1 takes -4 and x2 takes -4? Here x1 and x2 are independent to each other. Okay, so what will this be? This will actually be
1/9.
Okay. So this will be probability that x1 takes -4 times probability that x2 takes -4. So probability that x1 takes -4 is actually 0.3 times 0.3. So this will be 0.09. Similarly, you compute what is the probability that x1 takes -4 and x2 takes 1. So that will be equal to probability that x1 takes -4 times probability that x2 takes 1. So that will be like 0.3 times 0.2. So this will be 0.06. Like this you fill the table. So this will be like 0.3 into 0.5, and this will be 0.2 into 0.3, 0.2 into 0.2, 0.2 into 0.5. So I'm doing it quick. So try to understand that. So this is nothing but probability that x1 takes 1 times probability that x2 takes 1. So 0.2 times 0.2. So that is how it will be. So 0.5 times 0.3, 0.5 times 0.2, 0.5 times 0.5. Okay, this will be 0.15, 0.06, 0.04, 0.10, 0.15, 0.10, and 0.25. Okay, now what are the values that y takes? So if x1 is -4 and x2 is -4, y value is
-8,
-8, -3, -2, -3, 2, 3, -2, 3, 4. Correct? So what is the range of y?
-8,
-8, -3,
-2, 2, 3, 4.
2, 3. Right? So what is the probability that y takes -8?
0.01.
So there is only one possibility, x1 and x2 taking values -4 and -4. So that will be 0.09. What is the probability that y takes -3?
0.06 plus 0.06.
0.12.
Okay, so probability that y takes -3 has two different possibilities. Either x1 is -4 and x2 is 1, or x1 is 1 and x2 is -4. So there are two possible cases, and each of them has different chances. So the probability that x1 takes -4 and x2 takes 1 is actually 0.06.
Sir, I think you have missed -2 from the range.
-2 is
okay, there will be -2 also. Correct. So this will be -2 and 3. Okay, thanks. So this is 0.09, and what is the probability that y takes -3? This is actually the sum of probability that x1 takes -4 and x2 takes 1 plus probability that x1 takes 1 and x2 takes -4. So that will be 0.06 plus 0.06. So this will be 0.12. So similarly, you can compute for -2, 3, 2, 4. So what is the probability that y takes -2?
0.15
plus 0.1.
0.3.
0.15 and 0.15. So this will be 0.3.
3.
And 3?
0.2.
0.2.
So there are two cases again. So either x1 is 1 and x2 is 2, and x1 is 2 and x2 is 1. So 3 and 3. So probability that happening this particular case is 0.1. This particular event is 0.1 and this particular event is 0.1. So 0.1 plus 0.1, it will be 0.2. So for 2, so there is only one
0.04
possible case, that is x1 is taking 1 and x2 is taking 1. So that is 0.04. And finally we have 4.25. So now this is the distribution of y, but it is given in other form, that's it. So other form is like we have given like a table. Saying these are the values y takes, y taking values y, and probability that y is equals to y. Okay, there are -8, -3, -2, 2, 3, 4. So this is 0.09, 0.12, 0.3, 0.04, 0.2, and 0.25. Okay, so match this table with the options.
Sir, if time permits, maybe in the end, if you can give an example for continuous as well.
Yeah, we will take, if there is time, we will take. So this is understood, right? This discrete case. So if you have sum of two random variables where x1 and x2 are discrete, So you know how to find the distribution also, right?
Yes, sir.
Distribution
Yes,
of
sir.
y, and
Yes.
as well as the moment generating function. Okay. Shall we move ahead?
Yes, sir.
Yes, sir. Yes, sir.
Yeah. So let's come to this question. So this is actually, there is a random variable x that follows uniform 0 to 30. So by looking at this, tell me whether this is continuous or discrete.
Continuous.
Continuous, sir.
Continuous. That square bracket is there. That
Continuous,
square
sir.
Yes, it's continuous.
That square bracket is there. If you have in a curly
So if there is square bracket, it is continuous, is it? Is it like that?
Yes.
Yes, sir.
No.
It's a closed interval. It doesn't represent continuity.
It's actually representing an interval here. Okay. So if it is discrete, we should have given you like this. It is uniform.
Yes, curly bracket.
1 to 30 or 0 to 30. Okay. This is actually a set of values it takes. X takes only some values 0, 1, 2 like this. But here we have given an interval. So this represents x can take any value in the interval 0 to 30. Okay, it can take 0.1 or 0.02 or whatever the value, any value in between 0 to 30. So that will be continuous case. So here we have given x is uniform 0 to 30. We have defined a new random variable, which is 3 times of the defined random variable, which is y is equal to 3x. Now we have some set of 4 questions here. The first question is y is equal to g of x monotonic in support of x? What is monotonic?
Either increasing or either decreasing.
Yeah.
Function.
Either increasing or decreasing. Okay. Okay. So how to answer this particular question? So is it monotonic in support of x?
Yes.
Yes, it is monotonic. But how?
Can we make a graph?
Yeah. Just draw the graph of y is equal to 3x. So y is equal to 3x will be somewhat something like this. Okay. So this will be from 0 till 30. Okay. So this is y is equal to 3x line. So by looking at the graph, this is a straight line with some positive slope. So you can say this is a monotonic function. Correct?
Yes, sir.
So the answer is yes. Yes, it is
last,
monotonic.
The last value of y will be 94.
Yeah, why? Sorry, you.
I think he has lost his connection, so let's just wait for a few minutes.
Can Subramaniam, can you mute, please? Someone else.
Yes.
Meanwhile, sir, can I ask question to you, Professor?
Yeah, sure. I don't have a way of writing, and I actually don't have access to the mock paper, but I can try and answer as much as possible with words. We'll see.
So my question was with the previous question about the independence between two variables. So my question was, if x does not take a continuous value in the support of x, so like we saw it took half from 0 to 1, and supposedly it takes something else from 2 to 3, then how do we calculate the independence by multiplying?
So that's what he showed, no? The example he took was exactly like that, right? The x took values from 0 to 1 and 2 to 3. Y took values from 0 to 1, and he showed exactly how to compute the marginals and multiply and check independence, right?
Hello.
I mean, if the values are different in the range, in the support, so how do we calculate the independence? Like, how do we multiply? Suppose it's take.
I think Srikanth is back, but yes, I didn't understand your question. I think that problem was exactly like what you asked is what I felt. Anyway, I think let's Srikanth continue.
Yeah.
Carry on.
Okay, I'll post it in discourse.
Okay. Okay, I will come back to that particular question in the end of the session. Okay, we only dealt 4 questions right now. Okay, I have to be quick. Okay. Am I audible?
Yes, sir.
Yes, you are audible.
Okay. Yes. So we have a new random variable y which is 3 times of x. So we know the support of x, right? What is support of x here?
0 to 30.
0 to 30.
0 to 30.
So x. When
No,
x
it's for y 0 to 90, sir. 0 to 90.
99.
Yeah. So how do we get simply the support of y? How easily we can find the support of y?
Integrating.
Yeah.
Just multiplying by 3.
Yeah, just multiplying by
The
3.
support.
But why we are multiplying it by 3?
Because the function is y is equal to variance.
So if you know the continuous part here, so this is a continuous function. So y is equal to 3x is a continuous function, and x taking values from 0 to 30. Okay.
Area under the curve.
Area under the curve. So we are only talking about support.
Just support. Okay.
Just support, nothing else.
Okay. You need to get in order to get the support of y, you can actually find the distribution. So one way is actually like you can actually find the distribution, and looking at the distribution, you can actually get the support.
Yes.
But that is a standard approach that I will show you. But before that, I just wanted to tell that if you know the continuity thing, so if you know continuous functions and everything, so x takes values from 0 to 30, and y is actually 3 times of x. Okay. Whatever the value x takes between 0 to 30, y can take 3 times of it. So it can actually take from 0 to 90. Okay. So option B will be correct. Now we have to find the distribution of y. So how do we find the distribution of y? So we have
Sir, I have a question, sir. So support of y is including 90 or excluding?
See, this is continuous case, right?
Continuous, right?
Okay.
Doesn't matter.
Doesn't matter.
Okay.
Doesn't matter much, but as we have include 30 here, better include 90.
90 also.
Okay. Yeah. Okay. Thank you.
Sir, just a very small thing. So in exam, if we get 2 options, MSQ, and one is including and one is not, so we should take both the ones, right?
I think we should take both the ones, but we will be make sure that it will not repeat.
Yeah. I think these are bad options. We shouldn't have given both B and C.
No, sir.
Very
we have
confusing.
changed it. We have changed it in the actual mock, but I have just taken the previous version of the mock.
Okay. No problem. That doesn't matter too much.
Yeah, that doesn't matter, and we will make sure that this doesn't repeat. This doesn't come across. You will not be confused with the options.
Yes, sir.
Okay.
So which one is here correct? Open or the closed one, sir?
No, I will change it. This is not this. Okay, let's say this is uniform
Closed
0 to 30,
one.
0 to 90,
0 to
Closed one.
and this is something like what is the actual option we gave? Anyone remember? 0 to 10. Yes, yeah. 0 to 10.
Technically, I guess you can pick either one, but I think it's
Yes, sir. In this case, it's like B and C are correct, right, sir?
Yeah,
like if 90 open, we have
distribution wise, yeah, it doesn't matter.
So yeah, we change this option anyway. So now let us find the distribution of y first, and then we will discuss whether option B or C or anything. Okay, how do we find the distribution of y? If you know one random variable is monotonic to other random variable, so what is fy of y? How will be the density function of y be?
So if y is uniform,
J inverse of x.
F of x.
if y is uniform
Inverse
0,
one.
90, then we can't just use the formula for uniform.
What is the formula for uniform?
1 upon b minus a.
Okay. Acha, you are saying that you can directly do that. It will be
Yes,
3
I'm
times
asking. Yeah.
How you got that? This is how you get that, right? So you will get
direct formula substitution for uniform, which is 1
No,
upon
I think
90.
I'm sorry. I think the confusion is because we started discussing the answer before deriving it.
Oh.
Now Shrikant is going to try and show you how to derive the answer.
Yeah.
Wait patiently.
So we know the answer is 0 to 90, but we disclose the answer. That's it. We didn't find how we got this as uniform 0 90.
Yes.
Okay. So we know that one random variable y is a function of another random variable, and that function is actually monotonic. If we have this particular setup, if we know distribution of one random variable, this random variable x, we know how to find the distribution of y. We know, right? We know this particular formula. We have seen this theorem. It's like we defined it as a theorem in the lecture. Anyone recall this?
Sir, unfortunately, this
Yes,
formula
yes,
is not.
It is
Unfortunately, this formula is not there in the formula sheet, sir.
See, if we give this formula, then it's just the computation, right?
No. But I think maybe it can be added. I don't know if it can be added now. So we've already given the paper, I think, right? So I don't think we can make any changes now. Yeah, but next time we'll add it. This time you mug up this formula. We'll ask them to add it. So
okay.
Similarly, the movement formula is given in the next page, but it is not included in the quiz too.
Which one?
Yeah, you write on discourse. No, if you want more formulas added, I mean, I'm never against adding formulas. So,
right.
From my side, it's okay.
Yeah.
Okay.
I'll have to convince Shrikant a little bit. I think he believes in remembering. We'll see.
Right.
You are planning for open book policy, no, sir. Will it be covering in that one?
Can you be a bit louder, please?
No. I think let's carry on. Let's carry on, Shrikant.
Okay.
Let's carry on, sir.
Okay. Let us compute the PDF. Let us try to find the PDF of this random variable y.
Yes.
Okay. In order to find that, we need to know what is g inverse of y and what is the dg by dy. So this g dash. So y is 3x. Given that y is equals to 3x. So what is the g inverse function? G of x is 3x. If g of x is 3x, what is the g inverse of x?
3.
Y by 3.
Y by 3.
Y by 3.
Y by 3.
X by 3. Okay, anyway. If I say y, it will be y by 3. Okay, g inverse of y is y by 3. How do you get that? We have studied this in Max 1, Mathematics 1, if you remember.
Yes, sir. Just replace the x and y.
X
Yeah,
and
how
Y.
to find
So-
inverse of one function.
Exactly.
Okay, yeah. So use that and get this. So we will get g inverse of y as y by 3. So if g inverse of y is y by 3, and what is g dash of x? What is the differentiation function of g of x?
1.
So g dash of
1 by
y
3.
is 3.
1
So
by
if g
3.
dash of y is 3, what is g dash of g inverse of y?
G dash of x is 3, sir.
1 by 3.
1 by 3. G dash of x is 1 by 3.
It should be 3, na, sir, because it's
It should be
constant.
3. It's
See,
3x.
g dash of y is 3. So whatever the y inside variable is, the derivative is 3. So even if it is g dash of some g inverse of y, which is y by 3, so this is actually g dash of y by 3. So it doesn't change.
Isn't g dash of x equal to 3, right?
Okay, g dash of x is equal to 3. So if x is replaced by y by 3, also
it will not
it
change.
will not change. So whatever the x is, our slope, whatever the x is, g dash of x is actually 3.
That's a g inverse y by 3 can be just.
So this is actually 3. G inverse of?
G inverse y by 3. How, sir? I just forgot it, sir.
Okay. You just have to find the inverse, right? So g of x, you know, g of x is 3x.
3x.
Now take g of x as y. Y is equals to 3x and find x in terms of y. So x will be y by 3. Now what you have to do, you have to replace x with g inverse of y. That's it. This will be the g inverse function. Okay.
Yes.
So you just take g of x as y and find x in terms of y. Understood?
If I just take a note as well, just a second, sir.
Yeah. Understood, sir.
So this is 1 by 3. Correct?
Yes, sir.
This g dash of g inverse of y will be g dash of y by 3, and that will be 3 times fx of what is g inverse of y, which is y by 3. So what is fx of x?
3x.
This one. What is the PDF of x when x
1
is
by 30.
uniform?
1 by 30.
1 by 30.
Uniform 0 to 30.
1 by 30.
So this is 1 by
1 by
30 in the
p-
interval 0 to 30.
30.
And 0
Zero
otherwise.
otherwise.
Okay. So if fx of x is 1 by 30, what will be fx of y by 3? Any value y by 3?
1 by 30
X
only,
is
na, sir?
1 by 30.
Will remain the same.
So 1
Y
by
by
3
90.
times 1 by 30. This will be 1 by 90. Okay, what we got is, it will be 1 by 90 in the interval 0 to 90. 0 otherwise. So which distribution is this? So if it is like 1 by 90, so this 90 is 90 minus 0. So 1 by b minus a in the interval a to b.
Uniform.
Uniform 0 to 90.
90.
Sir, it will be y by 90, right? Not 1 by 90.
No, 1 by 90.
See, this is density function, not the distribution function.
Yes, sir.
Sir, but here you take fx of y by 3.
Yeah, fx of y by 3 is 1 by 30 only, right? So fx of x, it is
So y
independent
by
of
3,
x.
yeah, fx of y by 3 is just fx of x, right?
fx of x 1 by 30 also.
See, fx of x is actually 1 by 30, where
Okay.
it is actually independent of x. Whatever the small x is, it is actually 1 by 30. Whatever the value of x is, it actually takes the value 1 by 30. So fx of y by 3 will also be 1 by 30.
fx of x 1 by 30. How, sir? Like, can you just last?
If it is uniform, see if x is uniform between 0 to 30, so we know, right? This is the density function. PDF
Yes.
of x will be 1 by b minus a in the interval a to b and 0 otherwise. So here 1 by b minus a will be 30. So b minus a will be 30. It will be 1 by 30.
So it's here 10, 0 to 10, right, sir? Yeah.
If it is
No, that is
uniform
0 to
0 to
30.
No,
It is
he's
given 0 to
written that
30.
is 3. Yeah, he's
Sorry.
written it like
It
a
is
1.
given 0 to 30. Okay, my bad. So it is 0 to 30. Okay.
So I have a question in this. So if x is uniform and then y is just some linear transformation of it, like 3x plus 5 or something, then the y function will always be uniform, right?
If x is uniform, y will be uniform.
Okay.
Yeah, under linear transformation, yes.
Yeah.
The range will differ, but the nature will be uniform.
Okay, sir. Thank you.
Yeah. So whatever you said, if it is 3x plus 5, so the support will go from 5 to 95.
95. Yes, sir.
So it will be in the interval 5 to 95.
Yes.
But it will be uniform.
Okay, sir.
Okay. So yeah, third part is also done. The final part is calculate P of y less than or equals to 60.
So can you just repeat that when J inverse of y is y by 3, then why doesn't the differentiation is 1 by 3? Can you repeat that, please?
Okay. See, it is given that g of x is 3x. So this is the function we have.
Yes.
On another paper, sir.
What is the differentiation of this function? What is the g dash of x? What is the
3, sir.
differentiation? Derivative function. Yeah, 3.
3.
So
yeah.
this particular 3 is independent of x.
Yes.
Correct. This is a constant function. Now treat this g dash of x as a new function, some g of x, capital G of x. So this g of x is a constant function.
Yes.
Correct. Whatever x takes, it actually my output is 3 only.
Yes.
So if my input is y by 3,
then the output will be 3 only.
3 only. So what is this y by 3 actually? It is actually g inverse of y. So this is actually g dash of g inverse of y. Is actually 3.
Okay. Okay.
It should be like this should be above and this is below step.
You wrote it and rubbed it, sir. That's why that understanding.
So maybe it should be
sir,
above. I will write
yes,
it.
Sir, I understood it.
Okay.
Thank
you. So can I ask?
Yeah.
I was asking like when it's monotonic or non-monotonic, but traditional wave would always work, right? You don't have to follow the formula.
If it is monotonic,
like doesn't matter if it's monotonic or not. If the traditional wave will work.
What do you mean by the
traditional?
Through the CDF?
Yeah, like the first PDF of X, then
the
range, then CDF, and then
yeah, CDF method will always work.
Okay, so this is g dash of g inverse of y, which will be 3, which is g dash of y by 3, which will be 3. So this will be 3. Okay. Now we have to compute probability that y is less than or equals to 60. So what does this actually mean?
CDF till 60.
Hmm?
CDF till 60. FZ of 60.
So we know that y is actually uniform.
Why z? What is z doing there?
Oh, sorry, sir. Y. So it is uniform 0 to 90. So if y is uniform 0 to 90, what will be the distribution function be?
X minus f1 b minus a, or y by 90.
Y by 90. So if you don't know, you just integrate. Okay, so even though any process works, so this will be like 0 to y 1 by 90 dy 0, and this will be y by 90 in the interval 0 to 90 and 0 otherwise. So we just have to plug in.
Be slightly careful. 0 for y less than 0 and then 1 for y greater than 90. This is CDF, right?
Correct. Yeah, it's actually CDF, right? So it will be like y less than 0, it will be 0. 1, it will be like y greater than 90. So the same thing, 0, 1. Y less than 0 and 0 less than 1. Okay. So this will be like y by 90 and y is greater than 90, it will be 1. 0, y less than. Now we just have to plug in 60 in place of y. So fy of 60 will be 60 by 90. Correct? Okay.
Yes, sir.
Okay. Let us move forward. Okay, now we have x and y are independent exponentially distributed random variables. So this actually means, so x, y are IID exponential with expected value 1. So what is expected value 1 means? What is the parameter now? Expected value is 1, 1 by 1, which is 1. So here it is said that x and y are IIDs exponential 1. So what we have asked you to find is, what is the probability that x is less than 2y? So what is the first and foremost step need to be followed in order to answer this particular question?
Draw the graph.
Hmm?
Draw the graph.
Yeah, identify the region in which the random variable x actually takes values less than twice of y. So in order to identify that region, you just take the equality sign first and draw the corresponding line of it, corresponding straight line. So when it is x less than 2y, you take x is equals to 2y line. So x is equals to 2y line will be somewhat like this, right? This is x is equals to 2y, or it is actually y is equals to half times x by 2. This line is x by 2. So this, on this particular line, actually x is equals to 2 times y. So this line actually divides whole xy plane. If you take the whole line, whole xy plane into two regions, the above region and the below region. So top of the region and below region. And which region will represent x less than 2y region? X is less than 2y region.
Below region.
The
Below?
top one. The top one.
So in order not to confuse, you take any random point, some point. So here let's say 0 comma some 10. So check the correctness of this. So x value is 0 and y value is 10. So whether 0 is less than 20?
No.
No.
Sorry. Sorry, sir. Yes.
Yes. So even if you take one point, any point, every point satisfies the same inequality. So
Yes.
you choose any point here, some point which is above y is equals to x by 2 line. It will actually satisfy x is less than 2y. So this particular region, why am I drawing only on positive xy plane? Positive axis, first quadrant, only on the first quadrant. Huh?
X and Y belongs to 0 to
Support is
infinity.
greater than 0, sir, for exponential.
0 to infinity.
It's exponential.
Yes.
Yes.
So as it is exponential, x and y are exponentially distributed, the support of x and y are
0 to
greater
infinity.
than 0. So this is the only region we should consider. So this is the region, and we have to find. So we have to find the probability that x is less than 2y. This is actually the, if you take it in the 3D plane. So this is actually, this has some joint distribution, and you have to actually compute the area under the curve is actually the probability. Okay. And the curve is actually the function, joint distribution function. So joint distribution function, we will have one function for joint distribution, right? Let's say something like f of x comma y. So this is the joint PDF. So probability distribution function, joint PDF. So if you remember the calculus of two variable, so the area, if you want to compute the area under any curve, and the curve representing some function, you will have to integrate. You have to do the double integration of this function xy dy dx. Correct?
Yes.
If you remember.
Yes.
So in order to
Sir.
compute the okay, you understand with one variable case, right? One variable case, if you have some fx graph is like this, so distribution graph is like this, density graph is like this. If you compute the area under the curve, so area under this interval, you will get the probability that x lies in this.
Yes, sir.
Yes,
The
sir.
same thing we do for two variable case here. So here two variable means it's like 3D thing. So the curve is actually something like this. It will be somewhat like this. And we actually compute the area under this curve or the volume under this curve. Okay. So this particular under this curve gives us the probability of the required region. Probability. So area under the curve gives us the probability if the curve that represents is the density function. Okay. Now, so in order to find the probability that x is less than 2y, so our event is a subset of the whole possible cases. So this is one subset. Now we have to identify the corresponding intervals. So how do we identify the corresponding intervals? So for this, you fix, you take one as independent and one as dependent on the other. So if you take x is independent, so x can take values from 0 to infinite, right? This region covers all the values from 0 to infinite. Correct? X can take 0 to infinite. Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Sir.
So you fix the interval limits for x.
0 to infinity.
Okay, 0 to infinity.
Mm.
Okay. Once you fix the limits of x, now you take randomly one somewhere x. For some x, you just find the limits of y. So what will be the limits of y? So it will go till infinity, we know. So this will go to infinity.
X
But
by
where will
x
this
by
start?
two.
By 2.
X by 2.
So in terms of x, in terms of independent variable, we write.
Independent, yes.
So this will be like x by 2. So
X by
y
2
will
to
run from x by 2 to infinite. And what will be the, this is actually the joint PDF. So I just said this will be the joint PDF. So what is the joint PDF of two exponentially independent distribution functions?
Multiplication
Product.
of individual.
So fx of x, we know it is e to the power minus x. Lambda is 1 here. Okay, when x
Yeah,
is greater
so
than
e-
0 and 0
Hmm.
otherwise.
Same
Same thing for
same e
y
raised to
also.
the power minus 5.
So if fy of y, this will be like e raised to the power minus 5 when y is greater than 0, 0 otherwise. So the joint PDF will be fx of x comma y. This will be e to the power minus of x
minus
plus y. X plus y when x and y are greater than 0, x greater than 0 and y greater than 0, and 0 otherwise. Okay. So this will be like 0 to infinite, x by 2 to infinite, and this is e to the power minus x plus y dy and dx. Okay. Now we have to integrate this inside part first, and later we will integrate the outside integrate. So 0 to infinite. In order to integrate, again you can write it like this: e to the power minus x times e to the power minus y, e to the power minus y dy. So here the variable is y, so we have to keep x as constant here. So you can pull out this e to the power minus x outside of this integral. So that will be 0 to infinite e to the power minus x times x by 2 to infinite e to the power minus y dy dx. So what is the integration of e to the power minus x or e to the power minus y? What will be the integral of e to the power minus y?
e to the power minus
minus
5
x
upon minus 1.
minus 1.
minus 1
Correct.
equal minus
So
y.
this will be e to the power minus y upon minus
minus
1.
1.
And the limits are infinite and x by 2. So when x is tending to infinite, sorry, y is tending to infinite, e to the power minus 5, where will this e to the power minus 5 will tend?
0.
0.
0. So there will not, there we will exclude that term. That will be 0. Okay. So this is actually equal to 0 to infinite e to the power minus x 0 minus e to the power minus x by 2 divided by minus 1. Correct, dx. And this, if we simplify, we will get e to the power minus x times e to the power minus x by 2 dx. And this will be 0 to infinite e to the power minus 3 by 2 x, 3x by 2. Okay. Now tell me, what is the integration of e to the power minus 3 by 2x?
Minus 3 by 2x by minus 3 by 2.
What is what? E to the power minus 3x by 2 divided by
minus 3 by 2.
Minus 3 by 2.
Minus 3
Minus
by
3 by 2.
And the limits are again infinity and 0. Now the same thing. When x tends to infinite, this e to the power, this x tends to infinite, e to the power minus, it will tend to minus infinite, and e to the power minus infinite will go to 0. So the first term will be 0 minus e to the power minus 3 times of 0 divided by 2 divided by minus 1.
Sir, is it not minus 3 by 2 in the numerator itself, sir? Because e per u dx is e per minus 3x by 2 is e per minus 3x by 2 integral, and 3x by 2 will be minus 3 by 2, right?
See, your voice is too low for me. And
so I was thinking how minus 3 by 2 in the denominator. I thought it will come in the numerator itself. Maybe I'm missing
it will come in the
something, but-
numerator. Okay, this is an integration, it's not differentiation.
Yes, sir. So
okay, integral e to the power nx dx will be e to the power nx divided by n. If it is differentiation of e to the power nx by dx, then it will be like n times e to the power nx.
yes, sir, but
nx minus 1, sir.
nx
minus 1 e to the power.
No, it's correct.
Why nx minus 1?
Differential of e raised to x is e raised to x.
No, that is for
integral
x
of
to
e
the
per
power
x
n.
per dx is e per n by n. Okay. Okay, sir. Okay.
Okay. So here n is actually minus 3 by 2.
So Srikanth, sorry to interrupt. I had a general question for people here. So how many of you are seeing such double integrals with some e power minus and all for the first time? After a long time or something like that. I mean, if you've not had an engineering background, Maybe you can put something on the chat so that I get a sense of what fraction would be like that. And if you just raise hands, maybe you can raise hands. Yeah, if you just raise hands, I can also count. That seems to be okay. Okay, so there was a collab sheet that was created. I think for people who have not had this experience to look at such integration. So please look at that closely, try to figure it out. And this is a bit hard if you've not seen it before, but I hope it works out for you. Take a look at that collab sheet. Okay.
I'm mentioning to you the same, sir, and requesting a class on this sensor if it is possible.
Okay, just make a post on Discourse, okay? Requesting a class or.
Yes, sir.
Okay, shall we continue?
Yes, please.
Yeah.
Thank you.
So this will be the integration. Here n is minus 3/2. So that is how the integration will evaluate. So this is like e to the power 0. It will be 1 and divided by minus 3/2 and a minus outside, that will be 2/3 if you compute this, and this will be like again 0.66 and so on. And if you approximate this value 0.6. Okay, what we found actually, it's actually the probability that x is less than 2y is actually 0.67.
Sir, a basic question regarding the solution. Suppose if we are getting 0.66, so suppose in quizzes and all, will this 0.66 or 67, that range will be available, or
we will give the range. Okay, don't worry.
Right,
we will give it from 0.65 to maybe 0.68.
Thank
so
you,
that
sir.
you no need to worry.
Yes, sir.
Yeah.
So here e power minus 3/2. So like we will be giving the value for here. Like we have simplified this. E power minus 3/2 by minus 3/2, right?
Here it is 0.
It is actually 1, right?
Zero.
It is e to the power 0. This will be 1.
Infinity to 0. Okay. Okay. It will become 0. X will become 0. Okay. Fine.
Yeah.
Yes.
But we are providing calculator to you, right? You can actually compute e to the power minus 3/2 using calculator. If it is like 1, let's suppose say this is 1, the lower limit is 1, then you just have to know the value of e to the power minus 3/2. So that value can be computed using calculator, scientific calculator, which we provide. Okay. Okay, one question here is, now tell me, what is the probability that x is greater than 2y?
1
minus 0.6.
1 minus 0.6.
0.33.
0.33.
Okay. But see, you can actually compute again using the same things. If you don't know, we have asked you the probability that x is greater than 2y. Now what will be the limits? So you just have to double integrate fxy of x comma y dy dx. So now what will be the region now?
The below part will come now.
Below one will be the region, no?
Yes.
And you fix x as independent variable. So x will run from 0 to infinity. The limits of x is 0 to infinity.
Y is like from x by
from 0 to
x by 2.
0 to x by 2. Correct. So 0 to x by 2 and 0 to infinity. If you compute this, you will actually get 0.33.
Excuse me, sir.
Okay. Yeah.
Sir, actually, I'm finding it difficult to get the limit when such questions are asked that if the x is greater than 2 or any such inequalities type question. So I'm finding it hard to get the limit for x and y by the graph, I mean by the drawing.
Just now we have...
yeah, just now you said, but I was...
okay, what you have to do is, you have two random variables with you, right?
Yes.
You fix either you fix y as independent, or if you don't know anything, just follow this process. You fix x as independent.
Okay.
Independent. And in that region, whatever the region is, in that region, you just see what are the limits of x, like what are the values that x can take in that particular region. So if this is the region, this is the region, what all values can x can take? X can take
0 to infinity.
0 to infinity. You take the limits of x as 0 to infinity. Now you treat x as independent variable, random variable. Okay. Independent. So now that you fix the limits of x, now you have to fix the limits of y. And you fix the limits of y in terms of x.
Okay.
Okay. So let me take in new picture. So you see here. So let us suppose say this is the region we are looking at. Okay. So x runs from 0 to infinite. Okay. From 0 to infinite. So this actually means is, so for one value of x, you have to integrate, we are actually integrating y, and all the x's we are integrating. Next we are integrating all the x's. You fix one x and we integrate along that x, and later what we do is we actually integrate x from 0 to infinite. Okay.
Yeah.
Okay. In this case, that is how the double integration works. So you integrate y first, then you integrate x. So when you integrate y, you treat x as constant. So now that you know how to fix the limits of independent variable, right? So I already said you fix x as an independent variable and find what all values x can take. So it can take from 0 to infinite. So you just write 0 to infinite here. And next is you have to fix the limits of y. For fixing the limits of y, you choose any random x, let's say x, random x. X is any value. Okay, it can be 10 or 11 or 200 or 300. I just said x, that's it, on xy plane, and you draw a straight line. Once you draw a straight line, this straight line intersects this particular line at one point.
Yes.
Yes or no? Yes.
Yes.
What is that point? Y coordinate of that point?
If x is equal to 10, y is equal
So
to
if this is y is equals to some x by 2, so at x, what is the y value?
x by 2.
At x, x by.
See, is just a straight line, right? This straight line. On
Okay.
this straight line, there will be infinite number of points.
Yes.
Correct. So I just said I am choosing a point where my x coordinate is x. So if my x coordinate is x, what will be my y coordinate?
X by 2.
X by 2. So my y coordinate is actually x by 2. Just substitute x in the function, given function.
Okay.
So my y is x by 2. So for one fixed x, my y actually, so in this region, what all values y can take? If I fix x here, what all values in this line? So this is the line now. In this line, what all values y can take on this line?
X by 2.
X by 2.
X by 2 and above. Correct? So
Greater than
x
x
by
by
2 and
2.
above.
Yes.
So y runs from x by 2 to infinite. To infinite. It can take till infinite.
Okay.
Correct?
Yes.
So the lower limit of y is x by 2 and the upper limit of y is infinite.
Okay.
Okay, that is how. So fix one random variable and you find the limits of that random variable. With respect to that random independent random variable, you fix the limits of another dependent random variable like this.
Okay.
Okay.
So that's actually a very good description. But from a high level, if you want to understand what's going on, basically there is a region, a two-dimensional region, which you have to precisely describe. You have to describe every point in this region. And what is weird about this region is, you can say x takes values from 0 to infinity, But for every x, every value of x, y will not take the same set of values. Y will take a different set of values. And how different will it be? It also depends on x. So you have to actually compute for every x, what range of values y will take. And then only you can describe this entire region precisely. Okay, so I think that's exactly what Srikanth has said.
Yes. Yes. Okay, this is how you fix. Okay, I will give you two regions now. You tell me how to find the limits. Okay. So this
Yes,
is
sir.
because I'm spending time because this is actually important.
Yes, sir.
So if you don't know this, whatever the concepts you know, you cannot compute the final answer. You will
Yes.
stuck in between. Okay. Okay, let us take this first. So this line is actually, let us say this line is y is equals to 2x.
Yes.
Okay. So now I'm looking in this region, the below region. Now I need the limits.
Yes.
Limits of x and limits of y. So tell me, how do we start now? So treat x as independent. Okay. So what all values x can take? So you tell me now.
Sir, x will go from 0 to infinity.
Okay, 0 to infinity. Now what will be the, so you fix, okay, now what will be the limits of y?
For y, first we fix x at some point, and
so
if
we fix
we
x here.
draw a straight line, yeah.
Okay, this is a straight line.
Okay. So here is.
So now look at y.
Yeah.
So look at the support of y maybe. So you just simply look at the support of y for this particular x.
Okay.
So what is the support of y?
0 to infinity.
0, this particular x. Only this particular. You just forget everything. Left side of x and right side of x.
Okay.
So 0 to 2x?
Just a second. Yeah, correct. Just look at only this line, this particular straight line.
So it will be 0 to 2x, sir.
It will be 0 to 2x.
Okay.
So that will be the limit of y.
I see.
Okay. Now what if it is like this? So we are looking in the region, this closed triangle region.
Yes.
Okay, this is somewhere around 10. So at 10 it is actually changing.
Yes, sir.
This is y is equals to 2x line. And 10 it will be 20, 10 comma 20. This is something like 10 comma 20. This is the point 10 comma 20.
Yes.
Let's say this is actually x plus y is equals to 30 line. So this is y is equals to x minus 30.
Yes.
30 minus x. Okay. So this line is this. This line is this.
Yes.
Now I want the limits of. I want to integrate. Actually, I just wanted to integrate fxy of x comma.
Two steps.
Yes.
Two steps, sir.
We just.
In 2 steps we have to integrate.
Yeah, in 2 steps you have to do.
Okay.
Okay. So you fix till x is equals to 10 is one part, and from x 10 to infinite is another part. Infinite, or it will 30. It will close at 30. So from 10 to 30 is another part.
Yes.
Okay.
If we
this is a little bit advanced, it's good to know. I think don't worry about this such questions coming in the quiz.
Sir, but these are in activity questions. That is why.
Oh, it's there in activities.
Yeah,
Okay,
yeah, activity.
Good. Just to remind you, I mean, this is like the support of a function. Okay, there's a there's another function being plotted on the z-axis. You have to always imagine that. And this is a support, and you want to integrate inside that. Right?
Yeah.
I think that part is always important to visualize that there is some function for every xy, there is some z value, and that's defined as something, e power minus x minus y, whatever. So that is.
Srikanth sir?
Yeah.
In this case, for first part, the limit of x will be 0 to 10, and for
0
second
to 10.
part, and for second part, limit of x will be 10 to 30, right?
10 to 30. So this is 0 to 10, and the limits of y will be, so you
0
will take
to
any x in between
0 to
0 to 10.
20. 0 to 20.
0 to 20.
2x, sorry.
0 to
2x.
0 to 2x. 0 to 2x.
And
okay,
the other part is from 10 to 30, and here you choose any x, random x. So the process is same.
0
So
to 30 minus x. 0 to 30 minus x.
Yeah, 0 to 30 minus x. So whatever we are doing is same for every case. So we are actually fixing one limit, one random variable limits, and making it independent. And the other, for computing the other limits, what we do is we randomly choose one x, one point in between that interval, and corresponding to that one value, we actually compute the support of y. So for this x, the support of y is actually from 0 to 2x. So till 2x, it goes till 2x. So that is how the limit will be. Here it will be like from 0 to 30 minus x. Okay.
But the PDF should be y is less than 2x and y is less than 30 minus x to get the areas below the lines, no? I mean, to get this double integral to be true, this equation should be an inequality for less than, is it?
So you are actually
Hello?
defining this region, is it?
Yes.
Yeah. So
I'm sending. I was supposed to send you the message. Okay. Thank you, ma'am.
Yeah. So it will be like y is less than 2x and y is less than 30 minus x.
Thank you, sir.
So
Yes.
y is less than 2x in the interval 0 to 10, and y is less than 30 minus x in the interval 10 to 30.
Less than 30. 10 to 30.
Yeah.
Sorry for
So that is what
interrupting,
we are
but are there any more questions that you would be discussing, sir?
Yeah, there are a lot. I have to move ahead. I just stuck, like we are just discussing this thing. Okay, so this is how we get the limits for any double integrals. Okay.
Thank you, sir.
Yes, sir.
Okay. So yeah, one part is done here. So the other part is.
Sir, there's a one basic doubt is when you are integrating x square, and the result is x cubed by 3. Is that right? And sometime back we were talking about e power nx. So when we are integrating that one, what will be the result? E power
like e to the power
divided
nx by n. Yeah, nx divided by n.
Yeah, I think someone was asking about the basic doubt. Then I also got the same thing. Nx plus 1 or nx?
Nx only.
Okay. So if that is suppose if it's an integral of nx, then it is n times x squared divided by 2. Is that right? Not
e to the power f
not e
integration
power
is different.
It's not an e power nx. It's just an nx. No, it is not e power nx.
See, you are confusing with x to the power n integral.
Yeah,
so
x
this
to the
integral
power n.
is x power n plus 1 divided by n plus 1. So plus and minus will happen in this particular cases. So polynomial cases. So this is an exponential function.
Right.
Okay. So there will be
Sometime
nothing.
back somebody has raised it. Somebody has raised a question, but for some reason it got truncated. No issues.
No. This is different and that is different.
Thank you, sir.
Okay. So we just found out the probability that x is less than 2y as 0.67. So approximately 0.67. So we asked you to find the probability that, so this is a conditional probability here. So you can get it from. So probability that x is greater than y given that x is less than 2y. So I will
Yes.
just give you the region. We will just try to get the region, and later it's just the computation. Okay, computation part, I will leave it as an exercise, or you just do it. It's computation is easy. Whatever we did now, the same things you have to do for computation. But the region I will give you. I will show you. So the probability that x is greater than y, given that x is actually less than 2y. Okay. So this is a conditional probability. So this will be equal to joined divided by marginal. Correct? Like, so this will be like probability that x is greater than y and x is less than 2y divided by probability that x is less than 2y. So you see these two events, x is greater than y and x is less than 2y. Can we combine these two?
I don't think so.
Yes, we can combine these two. We can draw two lines. One is x equal to 2y, and the region will be between x equal to 2y and x equal to y.
That we will get it from the regions.
Because I do something and I'm getting like totally different things, like x equal to 2y is up and the region above it is, and x equal to y is below that and the region below that is taken that way.
Okay. So this is x is equals to y. So let us say this is x is equals to y line, y is equals to x, and this is y is equals to x by 2. Okay. So we said that this.
I made a basic mistake. Oh, okay.
So this is like x is greater than y. So x is greater than y means this particular region. Correct? This will be the region, right? If this is y is equals to x, x greater than y region will be the below region. Am I audible?
Yes, sir.
Yes, sir. You are audible, sir.
Okay, you are thinking.
No, you are clubbing two. You are clubbing two ideas, sir. You are writing something and telling something.
Okay. I just said this particular event, x greater than y. So x greater than y means this will be the region.
Yes.
You can do by taking 1 point, you can actually get it. Okay,
How
this
do
will be
you
the
do that,
region.
sir? How do you do that, sir? Can you quickly explain that, taking any arbitrary point?
Any arbitrary value. Here it will be like something, there will be some x and y value will be 0. Correct? So there is some value of x and y value is 0. So that value is actually greater than 0. So this is true. This will be true for this point. If for 1 point it is true, for all the region it will be true.
Okay, sir. Okay.
So this will be the region. And what is the region that x is less than 2y? We just saw this particular region. Correct? Which region is the combined region now? So we need x is greater than y and x is less than 2y. So the combined region is this. Correct?
Yes, sir.
So now this can be written like this. So if you don't understand how you write this also, it's fine. But identifying the region is important here. That's it. So if you identify the region now our main task is to find the limits.
Yes, sir.
Now tell me what will be the limits. So this particular probability that x greater than y, x less than 2y will be double integration of some fxy of x comma y dy dx. What will be the limits now?
For y, it will be from x by 2.
For x it will be
0 to
0 to
infinity.
infinity.
0 to infinity. You just see the green region part. So this is the region we are looking at. And this particular region, x will run from 0 to infinite. So it will go till infinite. And for one fixed value of x, so for limits of y, you fix x. So this is, let's say this is x. So that means this is the line.
By 2 to x.
So for this line, the support of y will be from x by 2
to
x.
To x.
Okay.
X
So,
only.
sir,
It will not go to infinite. So we are
Okay.
only within this region only.
So, sir, I can assume that if for this, if we have to take the limits for y, we fix x, and then in that region only we take the limit of y.
So whatever the region we are looking at, whatever the region we are required, in that region you just see the range
And,
of y.
And sir, for x, the limit won't change. I mean, it will be from 0 to infinity.
0 to infinity. So that is why we fixed x first. So
Okay.
fix one thing first, then we will compute the limits
Of
of
other-
another random variable in terms of the fixed random variable.
I see.
Okay. So that is how you should do. So this will be the limits. So this is the limit, and this we know. This is e to the power minus x minus y. Right? So you just compute the answer. Okay. You will get something around, I guess, 1 by 6 or something. So this will be 1 by 6, and this will be, this we have computed in the part 1. It is 2 by 3, and this will give you 1 by 4, which is 0.25. 0.25 as the answer. So you just cross check this. Now that I gave you we got the intervals, is just the integration part.
Yes.
So you just integrate it and find the value. Okay.
Yes, sir.
Those who have done, I guess you got 1 by 6 only. Correct? 0.25
Yes,
is
yes.
the answer. Correct?
Yes, correct. Yes.
Okay. Okay. That is how we solve that particular question. Okay. In order to get the probabilities, you just find the region first. And once you find the region, then fix the limits. And once you have the limits, you just integrate across that limits this particular fxy joint PDF.
Actually, sir, I got stuck in the limits, how to get that. But now you told, so I'm getting.
Now it is clear. You just practice few problems before you come to exam. Okay.
Yes.
So there are activity questions, many activity questions. Just open that activity question and try to get the limits.
Yes.
Yeah.
So one small doubt. If for the numerator part, we can multiply the probability that x is greater than y and x is smaller than 2y, right? Individual probabilities.
Why?
If we don't want to do the integration, simple.
No, I guess this particular x greater than y and this x less than 2y, these are
joint.
Are these independent? These are not independent events, I guess.
Okay.
They are independent, so we can do that.
They are independent, yes.
Okay. No, they are not independent. If they are independent.
Oh, actually, x or y are independent.
X and y are independent. If x greater than y and x less than 2y are independent events, then this conditional probability doesn't make any sense. So if this is independent of this will actually equal to probability that x is greater than y.
Okay.
Yeah, that will turn out to be very easy case. Is probability that x greater than y is 0.25? Compute this and check. I don't think you can actually take the product of two events.
Yeah, so one more way to convince yourself that those two are independent is if, for instance, if x is greater than y, can x be less than 2y? That's possible. So anyway, I think you can convince yourself that way also. But these two are dependent events in this case.
We can consider x greater than y as a new random variable.
That's
like that, and that will be a little complicated.
Means originally given that x is independent of y, but here x is greater than y will we should be considering that as independent, means new random variable. That way we can convince ourselves that they may be dependent.
Sort of, I think let's maybe move on, Srikanth. I think
Yes,
this
sir.
is
Yes.
okay.
Yeah.
Yes,
So
please.
this is how you have to do. Actually, you have to compute. This is how we solve the problems. This particular problem. Okay, let's go and solve one more problem. So here we have suppose 60% of adults in the age group of 45 to 50 in a country are male and 40% are female. Suppose the height in centimeter of adult males in that age group in the country is normal 160. It follows normal with mean 160 and variance 25. And that of females is normal 150 comma 25. If height of a randomly selected person is 160, what is the probability that the selected person is a male? Okay, so what are the key topics we should know at least, or which concept is this particular question
Base
related
theorem.
to?
A base theorem, sir.
Density.
Joint and
Base
continuous.
theorem.
Base, we can
Sorry,
solve it
total
with
discrete
base
and
theorem.
continuous joint density.
Correct. Discrete and continuous joint
Joint
density.
density.
So one random
Yes.
variable is discrete here, another random variable is continuous here. So first and foremost step is you have to identify what are those random variables are. So if I say x, so this particular x is a random variable. It takes value 0 and 1 if the selected person is male and female. Let's say female and male. Anything is fine. Male and female. Okay. So if the randomly selected person is male, x takes value 0. If the randomly selected person is female, she is female, then x takes value 1. So this is one random variable. This is a discrete random variable. Now we know that x is actually a Bernoulli with probability 0 we have 0.6. So no, 60% of adults in that age group is male. So it is like 60 by 100.
0.6.
So this is 0.6 and this is 40 by 100. This is 0.4. So this is a discrete random variable where it actually follows a Bernoulli 0.4. Okay, one random variable is this. What is the other random variable?
The height.
Correct. So height of a select height of a person. Okay, and this y actually dependent on the value that x takes. So y condition when x is 0 follows normal 160 comma 25. So these are the things we have to infer from the data given. Okay, so it is given that among the males the height is actually distributed in normal 160 comma 25. That means if my x is 0, then I know the distribution of y. So y given x is 0, I know this is normal 160 comma 25. And also the other thing is y when x is female, so when x is 1, that means female. So even I know the height of a person, the distribution of height of a person in the female group. It actually follows normal 150 comma 25. Now we have this setup. We know this is actually discrete continuous distribution.
Yes.
Discrete continuous case. Okay. Now, in order to find the distribution of y, what will be the distribution of y?
So the PDF of x equal to 0 multiplied by the normal distribution function plus PDF of x equal to 1 multiplied by the normal distribution function.
Correct. So Tx is the range. So probability of, so you have to, probability of x is equals to 0 times f of y given x is equals to 0 of y. So actually this distribution plus probability that x is equals to 1 times fy of x given 1 of y. So this will actually be, I hope everyone knows this formula, or I hope why I wrote this.
Yes, sir. Yes.
Yes?
Yeah,
Yes from
yes, sir.
everyone?
Yes.
Okay. So probability that x is equals to 0. So the range of x is actually 0 and 1.
0
That's it.
and
We have only two cases here. So this is f y given x is equals to 0 of y plus probability that x is equals to 1 times fy of x is equals to 1. So probability that x is equals to 0 is 0.6 into fy of x. See, this y given x is equals to 0, we know that this is normal with mean mu and variance 25. So what is the distribution? PDF function will be 1 by
sigma
root 2 pi sigma. Sigma is 5 into e to the power minus
x minus
y minus
y
160
divided by whole square.
divided by 2 sigma square
50.
So 50 plus it will be, this is 0.4 times. So probability that x is equals to 1 is 0.4 times 1 by root 2 pi into even this is also 5, sigma is also 5, e to the power minus y minus 150 whole square divided by 50. So this will be the distribution PDF of y. Okay, if you simplify this, you will get something like 3 by root 2 pi 25 into e to the power minus y minus 160 whole square divided by 50 plus something like 2 by 4 by, okay, 2 by 25, 2 by root 2 pi 25 into e to the power minus y minus 150 whole square by 50. Okay, now that we know the PDF of y, what is the question actually? What is the probability that, if a height of a randomly selected person is 160? So the question is, so it is given that y is actually 160. What is the probability that the selected person is a male? So that means
y condition x equals to 1.
So probability that x is actually 0 given that y is 160. So you just have to convert this statements into our statistical words terms. Okay,
So
this
can't
height
we
of a
write the
randomly
opposite?
Huh?
I mean, we can write y equals to 160 condition.
No, right? See, it is given. We have selected randomly a person and the height of that person is 160. We know that that is the condition we have given you. So the selected person is 160. And what is the probability that the selected person is a male? So we want the probability that x is actually 0 given that y is 160.
Okay.
So that is how, that is what you will confuse. So this is what you have to get by solving more problems. You will get how to convert this English terms, like this height of a randomly selected person is 160 into these things. Okay, we just have to find the probability that it is actually a male person, selected is actually male person, given that the selected person is 160.
160.
So that is how it.
Okay.
So we have to find this. So what we have to find? We have to find probability that x is actually 0 given y is actually 160. So this will be probability that this is actually conditional probability. So this will be probability that x is equals to 0, y is equals to 160 divided by probability that y is equals to 160. So it's actually, y is actually continuous here. We write fy of 160. So this thing, you can actually write it as f y given x is equals to 0, 160 into probability of x is equals to 0. Can I write it like this?
Yes.
How?
Right.
Yeah, we apply the
Bayes' theorem.
equation for the probability of discrete given continuous.
Bayes' theorem, sir.
Correct. From there you will get.
Bayes' theorem.
So it's actually, you can treat it like that. This is A intersection B of kind of thing. Okay. So you can write it like B given A times the probability of A. Okay. So, but here the terminologies are different. Okay. So this is how this is the value we have to find. Finally. So we know this. We know this. We know this. It's just the computation. So this is actually 3 by root 2 pi 25 times e to the power minus of 160 minus 160 whole square divided by 50 times 0. Okay, that is that thing. Combinedly I have written, that will be the divided by. So just substitute 160 here. So this is the fy of y. This will be the fy of y. We need fy of 160. Just substitute 160 here. So we are going to get 3 by root 2 pi 25 times e to the power minus 160 whole square divided by 50 plus 2 by square root 2 pi 25 e to the power minus of 160 minus 150 divided by 50. I'm not doing any new thing here. Okay, I just substituted 160 in the above. We derived the above density function, right? I just substituted 150 in place of y. That's it. So this is actually 0. So e to the power minus 0 will be 1. So this will be like, okay, anyway, this and this will get cancelled. This will be like 3 times 1 divided by 3 times 1 plus 2 by root 2 pi. Okay, there is no
root 2 pi is not.
So 2 plus 2 times e to the power
minus
100 by 50. So this will be like e to the power minus 2. So you just use the calculator. This will be like 3 by 3 plus 2 times e to the power minus 2. You can use the calculator
and get the value of e to the power minus.
So I think this will be roughly, you will get 0.92. Okay, just compute using the calculator.
E raised to power minus 2
parts and everything we can do. If we know the above steps, these are very easy steps. Is that the computational part? The main idea of this question is you should get these things. So there are 2 random variables and you should know what those random variables are and how are these we are getting and what actually need to be find. So that is the main question we have. If you understand what actually you need to find, then the problem is very simple. So you just have to find them. You know how to find, and if you don't know what actually need to be find, then you cannot solve any question. So the key idea for any question is read the question very carefully, understand whatever you understood, write it, convert it into this things, random variable, convert it into random variables, look out for what all we know. And the most important thing is what actually need to be find. Is it probability that x is equals to 0 given y is equals to 160, or probability that y is equals to 160 given x is equals to 0? What actually need to be find in any question is the key thing. So this computation part everyone will do.
Yes.
Okay. So this is what this is how we solve this particular problem.
Yes.
And yeah, and there is one more problem. So yeah, this is actually the same problem which we discussed above. See, here we have given you the PDF, joint PDF of 2 random variables which are continuous. So we have given you the joint PDF and we asked you to find the value of probability that x is greater than y. So I will quickly give you, we will quickly do the limits part, and the calculation part I will leave it to you. x greater than y, you just have to draw the x equals to y line, y equals to x line, and then identify which region represents x greater than y. So this region represents x greater than y. So for all these problems, draw the graph, identify the region in which we have to find the probability. Now the probability is, we just have to find the limits. The probability that x is greater than y is actually double integration of 3 by 2 x square dy dx. So what are the limits of x here?
0 to sorry.
0 to
1.
1.
No.
Okay. So we have some intervals also given, right? So look at the support of x and y. So the support of x is from -1 to 1, right? And the support of y is from 0 to 1. So we don't need to consider outside of our support. So these all not required. So it is enough to consider within the support. So outside support, the value is 0 anyway. So the probability will be 0. So nothing changes. So it is enough to consider within the support. So this is the region. So this is the region, -1 to 1 and 0 to 1, y 0 to 1 and x -1 to 1. So in this region, so if you draw x equals to y line and identify the region in which x is greater than y. So this will be the region where x is greater than y. So other region is x is less than y. Okay. So this is the region. Now the limits of x is from 0 to 1. Correct? We are finding the probability, or probability means, yeah, as Andrew sir mentioned, it's not always xy plane. You have to treat it always like there is some z axis, and the z axis represents the density function value. So there is something above here, and we are actually finding the area under that curve. So for that curve, we need to find limits in this region. So what are the limits for x? It is from 0 to 1. Now what are the limits for y?
0 to x.
0 to x.
0 to x. Fix 1 x and you can get it. 0 to x.
Yes.
So you just have to, now that we know the values of limits, you just have to integrate this.
Yes.
Okay. So shall I do, or?
Fine.
So we'll do, sir.
No, sir.
Will
No,
do?
sir.
Okay.
3 by 8.
Okay, just tell me what is the integral of 0 to x 3 by 2 x square dy?
1 by 3 x cube, sir.
X cube by 2.
X cube by 2.
X cube by 2.
Okay.
This is the mistake we do.
X by 3,
so
sir.
here we are
3 by 2
integrating along
x
y.
square into y.
Sorry?
So here,
with respect to y.
3 by 2 x square is actually constant when we integrate
Yes,
with
yes.
respect to y.
Yes, 3
These
by
are
2
the
x
mistakes
square.
we do. So this actually
Just y.
got outside.
Just
So
y.
0 to x dy dx. So this will be y.
Y.
And y limits x and 0. It will be like x. So this will be 0 to 1, 3 by 2 x square into x.
X cube.
So this will be like 3x cube by 2.
3x. Yes.
Okay. Now this is correct. This integration, whatever you said, this will be like 3x power 4 by
8.
So limits are from 1 to 0. This will be like 3 by 8.
3 by 8.
Okay. Yeah. So it will be like 0.375. Now the second part is, I will give you the region. You can find the integral. So what is the probability that mod x greater than y? So which region will it be? So even if it is mod x, you don't worry. You just take the equality sign. So you know what the graph of y is equals to mod x? Huh?
Mirror
V shape,
image of
sir.
y is equal to
V
x.
shape.
Like
It
a
will be
V.
like, yeah.
Y is
V
equal
shape.
to minus x will also be there.
So it will be like a V shape. Okay. Now, which region, whether the V side downside region or the above side region, will represent mod x greater than y?
Downside.
The below region.
Below.
Downside.
So now the region got added up. Complete region is like we have to find the probability of this region.
Right.
Okay. Both the regions. So we actually found this, and you have to compute this, and you have to add those two. It will give you the probability. So the limits are like, limits will be like, okay, how will be the limits?
0
Okay,
to
let us solve.
Minus 1 to
1 to
1 and
1.
0 to x.
Okay, so this will be like
Mine to
integral
0.
minus 1 to 0, and the limits of y will be
0 to
minus y to minus 1.
0 to minus x.
So in the interval minus 1 to 0, x is in between minus 1 to 0. You fix one x. If this is x, this is 0 to
y. 0 to x.
Minus x.
minus
X.
x.
Minus y.
Minus x.
minus x.
Minus x.
Yeah, this line is actually, what is this line actually?
Y equals to minus
This is
y is
y
equal
is
to minus
equal
x.
to minus x.
So the limits are from 0 to minus x. So this is 3 by 2 x square dy dx plus, so this probability plus this probability. So this probability we just computed. This is 0.375. So you just have to find this probability and add this. Okay.
Okay, sir. Yeah.
So will it be twice of
Yeah,
the
it
first?
will be twice. So yeah, this is some smart way of answering. No.
But the
No, how it will
distribution
be
is not
twice?
uniform.
Is different.
No, actually, it comes out to be twice.
It's negative, no?
It's not uniform, right? It's actually.
There's no negative here.
But
Even
it's
then
still
the
symmetric. No, I think
yeah,
it's
symmetric.
Acha,
So
symmetric.
Symmetric.
Yeah, the given function is 3 by 2 x square, right?
It's
So
area,
here,
no?
yeah, here it comes out. Here you can treat it like that. It will come out like that.
Yeah, I was surprised when, in spite of this being not uniform, the area came out to be twice.
No. See, because the function is actually symmetric. Okay. So the graph, if you draw the graph of this f of xy, this will actually be symmetric along y.
Is the answer coming as 0.75?
It will be like 0.375 plus 0.375.
Okay, 0.7.
75.
Okay.
It will come to be 0.75. Just check. These are just the computation. The hard part is like getting the limits.
Yes,
right? Yeah. Once you get the limits, it's actually integration thing. Okay.
Yes.
Yeah. You will get 0.75.
Yes.
Okay. Now let's come to this. So consider x and y denotes a retailer's daily cost and daily sale. The probability density functions are given to you. X and the probability densities of x and y are given. Now we are asking that there is some new random variable p which actually denotes the daily profit of the retailer. Now write p in terms of x. So the daily cost that retailer spends and the daily sale he does, what will be the profit?
Y minus x.
Y minus x.
Y minus.
Sale minus cost.
So the total sale he did and the cost he spent, sale minus cost.
Sale minus cost. Equals to y minus x.
Right? That will be y minus x. So the answer will be B option. Now, what is the probability that retailer's profit of a day is greater than 0? So what is this?
Probability that p is
Probability
greater than
y
0.
is greater
Y
than
is
x.
greater than x.
y minus
so
x is greater
probability
than
that
0.
p is greater than 0.
P is greater than 0.
That means probability that y minus x is greater than 0.
Which
That
means
means
y
probability
equals
that y is greater than x. So this thing we know now. So we have to find the probability that y is greater than x. And we know each of the marginal densities. And also we have given you that x and y are independent. We know the
Yes.
joint then.
Yeah.
What is the joint density now? It will be a product of
Product
marginals.
of marginal density.
Yes, sir.
fxx and f by y.
Therefore fxy of x comma y will be
e raised to power minus x by 2
half
into
times e raised to power x minus 2 into e to the power minus 5.
Yes.
Correct. So now we know the joint PDF and we know the region also. Which region will this y greater than x represent?
Above
region.
Above line.
And these are exponentially distributed, right? So the support is from 0 to infinite. So this will be the region. Correct?
Yes.
Yeah.
So the limits are from 0 to infinite, and what are the
X to
limits of y?
X to infinite.
X to infinite.
This is y is equals to x. So this will be from x to, so at
x to
some
infinite.
x, it will be from x to infinite.
Okay.
Infinite half times
Half
e to the
times.
power minus x by 2 e to the power minus y
Minus
dy
y.
dx. Okay. Everyone able to compute this, or shall I compute it?
I think the point 0.33.
Okay. Answer maybe you will get 0.33, but the computation part, everyone clear? Everyone
Yeah.
knows?
Yes, sir.
Sir, I have a
Yes,
doubt
yeah.
here.
So,
Yeah. What is the
Sir, can the limits be like if we say that dx and dy and the limits of x from 0 to infinity and y from 0 to x, will that be wrong?
Okay, you are right. See, that is what, if you know, there you are treating y as an independent variable.
Yeah.
Then that will be like 0 to infinity. Y limits are from 0 to infinity. Okay, y can take from 0 to infinity, and for fixed y, my x will go from 0 to y.
0 to y. Okay. Yes,
So
yes.
0 to
Okay,
y,
thank you, sir.
fxy of x comma y,
dx
dx
dy.
dy.
Yeah, right,
So
sir.
yeah, you
Thank
can
you.
do like that also.
Yeah, that was my also doubt.
Yeah, you can do like that. But those who don't know anything, just follow one method. Don't confuse among the two.
Sir, there is a potential chance of making error when we are defining the limits for the integrals, and dy by x and dx by dy matters, no?
dy by
dx or dx by dy. We can make an error in that one, no?
Whom to integrate first, sir? That's what he is asking.
Which one to integrate first? Is it
Yes.
that thing?
Yeah.
So whatever the inside
Because
limits
this is tied up, is it? No, the limits are tied to the order in which we are putting dy by dx, is it?
You want to integrate with
No.
respect
Why?
to x?
Your question is why we are getting this dx and dy? Is that the question?
No, should we get a different result if instead of dy by dx, if I put dx by dy?
Of course, you will get a different result, right?
Yeah, but how do we really avoid that error? That's what I'm asking.
Avoid that error is
relationship?
basically whatever the limits you are taking for the first integral. So if the limits are for x, then your dx should come, you should integrate x at the end. So first this integration is happening, right? And the limits of this integration is for y. So y is equals to x to y is equals to infinity. X is equals to 0 to x is equals to infinity. So we are actually integrating y.
Right.
The inside one actually dy.
Outer to outer, inner to inner.
Yes, that's a crude way of remembering that one. Outer to outer, inner.
Yes, outer to outer, inner to inner.
You blindly want to remember, that is how.
No. But definitely we get confused at some point in time.
Yeah. So depending upon the limits only we actually fix. Okay, if you are actually integrating with respect to y, then you will have dy. So the inside will be inside and the outside will be outside. Okay, whatever you said is okay.
All right, sir.
Okay. Yeah.
So, sir, these both will give a different result, right?
Which both will give different result?
These two limits which you have taken for
this and
first.
This.
Yeah.
No, these two are same.
How can
actually.
they give different results?
Both will give the same value, 0.33.
Oh.
So that is why I say if you are not okay with these things, just follow one integral, one method.
Okay.
Okay. Both are same actually.
Both are same. Okay.
Okay. Now, yeah. So this is the new question. Like from past experience, it is known that the number of tickets purchased by a person standing in a line at the ticket window for a movie follows a distribution that has mean mu equals to 2.4 and standard deviation sigma is equals to 2. So this is the first statement given. So what it says, if I take any random variable x, what this x represents? X is the number of tickets
purchased by a person.
Purchased by a person. Okay. So for this x, it is given that expectation of x, which is mu as 2.4, and the standard deviation, which square root of variance is also given to us, which is sigma is 2. Okay. So that means what it says is actually the person standing in the line, on an average, they are purchasing 2.4 tickets, but it is in real sense it is wrong, but no one can purchase 2.4. But the average turned out to be 2.4. Like just say there are some 24 people, there are some 10 people, and out of 10 people, only 24 tickets have been sold. So if you want to compute like this overall distribution, they have computed the average. So the average number of tickets purchased by a person is 2.4 with a standard deviation of 2. That means so there is some variation. So the first standard deviation. So 2.4 is the
Oh, Srikant's collection has been lost again. Oh, maybe he's back. I don't know. Let's wait for a few minutes.
So can I ask one just very small general question?
Yeah, sure. Go ahead.
So like I always find difficulty, like I'm like slowly and slowly I'm engaging in concepts related to stats which are really required. So but I always find difficulty in like building a relation between the practical implementation of when it comes to the concepts of stats. So is there any way like where I can work on that more?
So the one way I would suggest is when you see data, right? You have to imagine what generated the data. Okay. Is that okay? There would have been some event or some activity or something, right? That would have generated the data. That's why I keep giving this IPL example, right? When you see IPL data, IPL matches are happening and that's generating this data. And then from that event, lot of data can come. From there, you can start defining random variables, right? All these random variables will be related, no? Like I could define the number of runs scored by the first team as one random variable. A number of wickets taken by in the first innings as another random variable. You can define many random variables like that from that one big complicated event. And then they will have some distribution. How do you find the distribution? You look at all the data so far, make some histograms, make some guesses as to what they are. You know, you can go in that direction, see if the two random variables are dependent, see if you want to model one as continuous, something else discrete, maybe something is better that way, etc., and then you will get an idea. Okay, that's the best hint I can give you at this point. As you do more and more, this will become clearer. Okay.
Okay, sir.
So
Thanks.
actually, this is the problem, that when we look at the data, like I don't know, like how to start, like which distribution will it be, that stucks. Like
You have to
then,
start with descriptive looks at histograms and various things, right? And then you should try to think of what makes sense, maybe. But I don't know if many people do that, but I think definitely looking at histograms and all that helps. Okay, because that gives you the shape, no? So you get a sense of it.
okay, sir.
Okay, so sorry, I'm just disconnecting. Always this happens always. So sorry for that.
No problem, sir.
Yeah.
Please continue.
Okay, let us continue.
Okay. I provided some comic relief in the middle.
Okay, sir. This was actually every time it will happen, sir. And even many of them know, I guess. When I take the session exactly after 2 hours, I will automatically get logged out. I don't know why. Okay, let's come back. So X is actually a random variable that represents the number of tickets purchased by a person standing in a line at a ticket counter. So it actually has an expectation value 2.4 and standard deviation is given to be 2. So this is what we can get from the statement 1. So the second statement is like, suppose that few hours before the start of movie, there are 100 persons standing in a line to purchase tickets. If only 250 tickets remain, what is the probability that all 100 persons will be able to purchase the tickets they desire? Now tell me how to read this. What we can get from this?
We have to find the probability that x1 plus till x10, x1 and x10 they represent the 100 persons, like x1, x2, x100 sample.
So let's say xi represents the number of tickets. Number of tickets purchased by ith person in the line.
Yes.
So there are 100 persons, and also everyone will purchase some tickets, few tickets. So the total number of tickets purchased by all those 100 persons will be x1 plus x2 and so on plus x100. This is what the total number of tickets purchased by those 100 people, 100 persons.
Yes.
Correct. If xi is the tickets purchased by ith person, so if you take the sum over all the tickets purchased by all the 100 persons, it will be like total ticket purchased by these people, these 100 people. And what we are asking is, if there is only 250 tickets remain, what is the probability that all the 100 persons will be able to purchase the tickets they desire? So that means if this sum, if you wanted to, x1 is the number of tickets that the first person wanted to buy. X2 is the second person wanted to buy, number of tickets the second person wanted to. Like this, x100 is the 100% desire number of tickets he has to purchase. So if this is less than 250, then everyone in standing in the line, all the 100 persons standing in the line, they can purchase the number of tickets that they desire. Correct?
Yes, sir.
If this sum is greater than 250, then few people cannot get the number of tickets that they desire. Right?
Yes.
So we are asking the probability of this particular event. So what is the probability that the total number of tickets purchased by these 100 persons will actually be less than or equal to 250?
CLT, sir.
Okay. Sir,
so what should
one doubt.
So
one doubt here. If it is less than 250, how you get this less than 250? I mean, if the 100 persons
total tickets are there.
So what is
Given in the
total
question,
number of tickets purchased by the persons? 100 persons?
250.
No. It's not
Sorry.
250. See, let us say you understand this x part.
Yes.
How I defined my random variable x.
Yes.
It actually represent the tickets, number of tickets purchased by a person. Okay?
Yes.
Do you understand how I define this new random variable xi?
Yes.
It's actually the number of tickets going to be purchased or purchased by ith person standing in the line.
Okay, sir.
So that means x1 represents the number of tickets that the first person going to purchase.
Okay.
Okay. What is this sum of all the 100 random variables represent? If this is the number of tickets purchased by person 1, this is the number of tickets purchased by person 2, and this is the number of tickets purchased by 100th person. What will be the sum of all those things will give me?
Total number of tickets purchased by all 100 persons.
All the 100 persons. So this is
Sir,
actually.
sir, I have a basic question here. Can I clarify that one? I think the question is about 100 people buying all the 250 tickets, no? As per the equation, there is a potential chance of.
It should be less than equal to 250, sir, right?
Yeah. See, there are 250 tickets. Okay, treat it like a real example only. You went for a theater, and you are the 99% standing in the line, and you know that this theater capacity is 250, and only 100 people turned out to watch the movie. 100 people stood in the line and turned out to buy the tickets.
So it doesn't mean that all the 100 tickets should be consumed by the 250 people. As all the 250 tickets should be consumed by the 100 people.
Correct. See, what if every person only wish to buy only one ticket?
Then it will be 100.
They desire to purchase only one ticket. So that is every person's desire, right? It may also happen. Even that will also be a possible case, right? In this particular thing.
No, sir. Mu is 2.4.
See, mu is 2.4. Okay, man. I'm not talking about it. Those who have stood in the line, all those 100 people, if all the 100 people desire is to buy only one ticket, will their desire get satisfied or not? All the 100 persons desire got satisfied or not? Will be get satisfied?
In your equation, it is a possibility that the whole 100 people will be buying less than 250 tickets.
Yeah, less than 250.
So some tickets are left.
Okay. If they
So
if the desire of all the 100 persons, if the total number of tickets they wanted to purchase is, if it is actually less than 250, then actually whatever I thought I can buy that many tickets, right?
So suppose if it is that all the 100% consumes all the 250 tickets, the equation should be equal to
250. Right? So that is like that will be like equal to 250.
But here, how can we get that if it is equal to or less than? Because it's written that they desire to purchase the tickets. I mean.
Yes.
Yeah. See, that desire, their desire.
Desire word is. Does that mean?
So desire means if I wish to buy one ticket, I should be able to buy that one ticket. If I wish to buy 4 tickets, I should be able to buy those 4 tickets.
Okay.
So every 100, all these 100 persons will have their own desire to purchase number of tickets.
It should be less than equal to 250, right?
Yeah, it is less than or equal to 250. Please wait. Okay. So what am I saying is, so this particular first person will have some desire, like maybe he just wanted to buy 3 tickets. So he will get all the 3 tickets because there are 250 tickets. And the second person will buy some 4 tickets or 3 tickets or 2 tickets. Like this, even the 100 person, if the 100 person wish to buy some 4 tickets, even he should be able to get those 4 tickets. When will this can happen? If the total number of tickets purchased by all these persons are less than 250, then this can happen. Like when I say total number of tickets purchased means their desire. Let's say their desire. It's not purchased, okay? Number of tickets
desired.
Yeah, desired by ith person. Okay. Now this will give you some clarity, I guess. So x1 represents the number of tickets desired by ith person, xi. So this summation will give me the number of tickets
desired by 100
desired by
persons.
these 100 people.
Okay.
Correct. So this desire should be satisfied. When will this get satisfied? If this sum is actually less than 250 or equal to 250, they will get tickets. If this sum is more than 250, then few people may not get the desire got satisfied. Understood?
Can you clarify this, sir? If the ticket is more than 250?
See, if their desire is more than 250, let's say if their desire is not even 200, 250 chodo, there are only 3 persons in a line. Okay.
Okay.
And there are only 5 tickets. Okay. If this person desire to buy some x1, we don't know, he has some desire. Number of this actually represents the number of tickets desired by this first person.
Okay.
Can he desire for 5 tickets?
He can.
He can, because he is the first person. Can he desire for 6 tickets?
No.
No, as there are only 5 tickets, he cannot desire for 6 tickets. If he can desire for 5 tickets, let's suppose say he desired for only 2 tickets.
Okay.
Then there are only 3 tickets left for the second person.
Yes.
When he goes to front, there will be only. Please, everyone.
There is some.
Mute. Okay. So the second person will have only 3 tickets left in the counter. And what if his desire is 4? Will he able to satisfy his desire?
Okay. No, he can't.
No, right? So what we are actually, when will these 3 people desire get satisfied? If this sum is actually less than 5, then their desire gets satisfied. If he desire for 2, if he desires for 4, and if he desires for 1, then the total number of tickets desired by these 3 people is like 7. But the only tickets available in the counter is 5.
So it means that he can't desire more than the available tickets.
More than the available ticket, and
whatever
few
is available.
Few people
won't
get satisfied.
Right.
Yeah.
Right.
So
thank you, sir.
What we said is everyone, so all the 100% people desire
Should
is
be.
getting satisfied.
Okay.
Yeah. So therefore, the sum should be less than or equals to 250.
Yes, sir.
Okay. Okay. So
Thank
this is the actual. This is what we have to find. This is what we have to find.
Yes.
So how to find this is the second question. So we know the distribution mean, distribution variance, or standard deviation, and we have some 100 samples out of it. And we want the sum of those 100 samples less than or equals to 250. What 250. We can use?
We can
CLT.
use CLT, sir. We can try to
CLT.
X.
So like you have to find the probability of this, but you don't know the probability of this particular distribution, right? How to compute the probability, or you don't know what this is, f x1 plus x2 plus x100 of 250. We don't know how to find the value. What we do is we actually convert this x1 plus x2 plus x100. If you treat this as one new random variable y, we actually convert it into standard normal and we compute the probability, right? So if this is probability that y, let us say this is y, so the sum is y, probability that y is equals to less than 250. So if y follows some distribution, what CLT says?
Y minus expected value of y divided by standard deviation of y follows standard normal.
Standard normal.
0, 1. Yes.
Yeah, 0, standard normal. Correct?
Yes, sir.
So what is the expected value of y?
It's
2.4.
2.4
into 100.
Okay, is it 2.4 or 2.4 into 100? This is like expected value of x.
2.4 into 100.
So this will be 100 times 2.4, which is 240.
Okay.
What is variance of y? Here observe one more thing. X1 is independent of X2 and X2 is independent.
Yes, yes.
Yes, sir.
Correct. So how many number of tickets I desire is independent of the person standing in front of me and standing backside of me.
Yes, sir.
Yes, sir.
Correct. Okay. So the variance of y will be
16 times
16.
N sigma.
It is 2, so 200.
So it's
Square
actually
root-
so
square root
sigma
200.
is 2.
4.
So sigma square will be 4.
Yes, sir.
4 times
4 times, sorry.
100. 4 times 100.
100.
400.
So it's actually again the same thing. Variance of x1 plus x2 plus and so on
Till
x100.
x100.
So this is like 100 times
Variance
of
of
x. So
which
this
is
is like
4.
100 times 4, which is 400.
Yes.
Yes.
Now what we have to do? We have to do some manipulations, like we subtract 240 and we divide it by square root 400. And this is less than or equal to the same thing. Whatever we do on the left side, we have to do on the right side. 250 minus 240 divided by 400. So this is standard normal set.
Yes.
Correct. So this is probability that z is less than or equals to 10 by
10 by 20.
So this is half.
Half. Z less
The
than.
probability that z is less than or equals to half.
Fz
This is
of
equals to fz of
0.5. Okay.
So option C will be the correct answer.
Right.
Okay. Yeah. So this is all. So here also see, getting till here is the difficult
Is a
part.
difficult part. Yes, sir.
From here,
if we
these all things we know.
Okay.
Yeah. So try to understand the question clearly and solve it accordingly.
Yes, sir.
So why does 400? It is root n sigma, right? So it should be 100 into 2.
Root n sigma, right?
Yes.
So if you remember the formula root n sigma, okay. What is root n?
So what is n?
Root
10.
100.
Root 100,
10.
okay.
So 100,
Into 2.
root 100 into
10 into 2,
Yes.
you are going to get
Yes.
20.
20.
The same thing. See, this formula root n
Yes,
sigma
sir.
is actually square root of variance of y.
But where did we get that 400 from? That is my question. Root 400.
Variance of y. You compute the variance. See, y is actually the sum of 100 random variables. Okay.
Yes, sir. Correct.
Okay.
Okay, so just 100 into 400. Okay.
100 into
Yeah,
4.
if you want strictly from the formula, 400 is n sigma square.
400 is n sigma square.
Into sigma square. Okay. Yes.
Okay.
Yes.
Okay.
Okay. So this is the final question we have.
Yes.
So there is a random sample of size 50 is collected from a population with a standard deviation of 10. So we have given you the population standard deviation to be equal to 10. Let A be the event that the sample mean x bar is within 4 of the population mean mu. So for this we actually gave you, that means the event A is actually mod of x bar minus mu is less than 4. Okay.
Yes.
So this is what, see, this particular sample mean is within 4 of the population mean mu. That means,
yes.
So if you see the difference, that
four.
is actually less than 4.
Less than 4.
Mod of, yeah. Now what we want is find a lower bound on this probability of this event A using the weak law of large numbers. So what is weak law of large numbers?
Probability that
if I have any random variable x with parameters mean mu and sigma square, and if I have sample mean which is x1 plus x2 plus and so on xn divided by n, what does weak law of large number say?
probability that absolute value of x bar minus mu
greater than
greater than
some delta will actually
Less
be
than.
less than or equals to
variance by delta square.
variance of
Sigma
by
square
delta square.
x bar by delta square.
Delta square.
Correct? Yeah. Now we have to compute this. What is variance of x bar now? So if you know the population standard deviation, what will be the variance of sample mean?
Sigma square by n.
Yeah. So variance of sample mean will be population variance divided by n. So that means sigma square by n. Correct? And the expectation will be mu itself.
Mu.
So now it is like probability that x bar minus mu is greater than some delta is less than or equal to variance of x bar is sigma square by n delta square.
And delta square.
So here we have given you the delta. So delta is 4 here. And also we have given you the standard deviation, which is 10. Okay.
Yes.
So probability that x bar minus mu greater than 4 is actually less than some 10 square divided by, we have collected 50 samples
50
divided by 4 square. But this is not the event. This is not our event.
Yes.
What is the event?
Less than 4.
Less than 4.
So how to get
1 minus this one?
1 minus this.
So if this particular probability is less than this, the complement event probability will be greater than 1 minus of this. X bar minus mu less than 4 will be greater than or equal to 1 minus 10 square by 50 into 4 square. So this will be like greater than or equal to 1 minus, is that the computation? 50 into 16 to 8. So it will be like greater than or equal to 7 by 8. But what we asked you? We asked you to find the lower bound on the probability of A. So what is the lower bound of? So this is actually P of A is greater than or equal to 7 by 8. So what value should we enter as the answer now?
7 by 8.
At least 7 by 8.
Yeah, this is at least 7 by 8.
At least 7 by 8.
So
0.875.
what is the least value? 0.875. So this is the answer for our final question.
At least.
Sir, I have a doubt regarding a confusion regarding weak law and central limit theorem in practice assignment.
Okay, we will deal with that. Okay, before that, now that can I hope everyone know how to solve each and every question in mock paper?
Yes.
Yes.
Yes, sir. Yes, sir.
It's not about solving, it's about understanding how we solved it.
Yes, sir.
Yeah.
Yes, sir.
Okay.
So will quiz to be similar to this?
See that mark distribution and everything are similar, but we won't give you the same questions, right?
No, that is correct, sir.
Yeah.
We are not asking for that, sir.
Sir, will there be questions from week 1 to 4?
The same, whatever the weak distribution we have given for mock, it will be the same for quiz 2 also. So if you have seen some 2 or 1 question from week 1 to 4, the same will follow in quiz 2.
What will be number of questions, sir?
Same thing. That also the same. It will reflect the mock. So here we have some 10 questions. If you treat it like subparts, we will have some 18. So even in quiz 2, you will have somewhere around 18 to 20. That's it.
Couple of clarifications from my side, Srikanth, just to emphasize something. See, for instance, in this question 9, you're doing a calculation with CLT, and that's only an approximation. Okay, so you should remember that always. So if the question says, what is the probability that all 100%? What is the approximate probability using CLT that all 100% will be able to purchase the tickets?
Yes.
I think that's a slightly better question, and you should know that it's an approximation.
Yes.
It's a pretty good approximation, works quite well in practice. Okay, that's one point I wanted to make. The other point was, I think when I do it in the lectures, I placed some emphasis on this root n division and all that. That's because I wanted to show some convergence and all that, and that's why it's important. But in practice, people just simply will take this x1 to x100 and approximate it as a normal with mean as what he calculated 240 and variance as 400. That they'll directly do that, and that's something to keep in mind also. And the final point is in the next question, the question number 10.
Yes, sir.
So what we are actually using is Chebyshev's inequality. Okay.
Yes.
So Chebyshev's inequality, when used on sample mean, gives rise to this weak law of large numbers. Okay. So you should always, even though we always in our questions we always say weak law of large numbers, weak law of large numbers, it's actually Chebyshev's inequality applied on sample mean. So, but it's okay. I think this is the most standard proof for the weak law of large numbers. There are other things also. Okay. Yeah, yes. I think those are the points, because technically there's another version which has a different proof. Anyway, doesn't matter. These are some minor points. I just wanted to emphasize them so that when you talk about it, you use the correct language and it's clear. Okay.
Yes.
All right. All the best.
One query over here regarding this.
Yes.
Just how you explained about weak law of large number and CLT. So is it like that CLT always give better result than WLLN? Or
so see, WLLN is a bound. It's a proper bound. CLT is never a proper bound. It's only an approximation. It could be below or above. We don't know. Okay.
Okay.
So I don't know about better and all. Yeah, I think I show a lot of examples in the lectures for different cases and how it looks.
Yeah, it was always better at that time. So I just asked in general, is it like that or not?
In general, people use CLT like that always. But it can vary.
So can it be like in some cases where weak law of large numbers gives better result than CLT? Is it like that?
Yeah, I think you can cook up a situation like that. Should be possible. Like for instance,
going by your intro on both WLLN and CLT, you had given a lot of hype on CLT than WLLN.
Yeah, that's generally true. I think, but so I think the strength of law of large numbers is there is something called a stronger version. Okay. And the stronger version works even without this sigma square. So if you have random variables which don't even have a variance, even then this law of large numbers works well and all that. Well, CLT would be sort of totally collapse. Anyway, so those are slightly more complicated points. So law of large numbers in another version has wider applicability than CLT.
Okay.
So that way it's better, but in most practical problems, CLT will give you better answers than this side.
Okay. Yeah. Okay, sir. Thank you.
Yes.
Thank you, sir.
But it is not a bound. It is not a bound. That's something to remember. So if you want to do some proper theory calculation, you will see people will hardly use CLT because it's not a bound. It can go up or below. We don't know.
Okay.
We must not.
Okay. Thank you, sir.
Okay, so
do we have any plan to address the remaining 8 questions?
Remaining 8 questions?
No. All are done. All are done.
10 questions.
Hey, that was
all questions can be.
Every question is done.
There are subparts.
Total 18.
Yeah, there are subparts here. So
okay. Okay, so I'm going to sign off right now. Thanks a lot,
sir. Good night,
first of all.
Sir.
It's been a very long session.
Thank you, sir.
All the best for the exams. Hope all of you do very well. Okay.
Thank you, sir.
Thank you very much, sir.
Thank you so much.
Excuse me, sir. I have a doubt.
Yeah, I will take some few doubts. And as far as our agenda, we are done. Okay.
Yes.
Whatever the mock questions we wanted to discuss, we have discussed it completely.
Really a great session.
Sir, for coming on screen.
Sir, if we follow mock, then sir, how much marks we will secure? It is 50% or more than 50%?
See, that is what I say. If you just blindly follow, it doesn't give you anything. If you understand it correctly, how we are solving the problem, it will definitely help you and it will definitely make you pass.
So this CLT question was really...
Not even pass, you will get good scores.
Okay, sir. Okay. The approach, the question, how do we approach the question?
How to approach each and every question.
Okay. Understood.
Thank you, sir.
Thank you.
So can I ask my doubt?
Yeah, please. So whoever has some small doubts, please
So
say
this
that. I will
PDF will be shared, right? I mean.
Yeah, this will be shared. This will be shared.
Okay.
Okay.
Yeah.
Srikanth, am I wrong in really referring the Mark 2 question paper has 18 questions?
No, it's not
That
wrong.
was sub questions actually.
Including sub questions,
it was 18. Main question it was 10.
So the
no, there is a 2 sections. Please use below the information code.
Yeah. Like that. See, each and every question has some
They're not
subparts,
sub
right?
questions. They're not. They're still bigger questions. Like for example, if you take 15 and 16 is similar to the same questions what we discussed about.
So, Mr. Mohan,
yeah.
like for 15 and 16 in our mock, sample paper what we have received, they are marked differently, right? But when Srikanth sir has explained, so they are subparts. They have been taking the subparts, like many questions. Question number 1, then part 1, part 2, part 3, something like that. If you see from starting,
see for example,
he has covered all the questions. 18, yeah, like here, yeah.
See, for example, you might have this for this a question number and for this another question number. But I included it as a single question.
Correct.
Okay. That is how it became 10 questions only. Okay. Yeah, Tanvi.
Yeah.
Yeah.
So can you open practice assignment 8 or should I speak up the question?
It would be good if you speak up just the question.
Yeah, I'll tell
Which
you.
week is it?
So it's week 8.
Okay, week 8.
Yeah, so so x1 till xn they are independent, like IID samples, and they follow Poisson distribution with lambda equals 4.